Hey everyone, hope you're having a good day so far. We're back to the CTC app today. It's been a bit since we've gotten to see our old friend, since we did 16 hours of caterpillar puzzles. So we're back now. So we started doing caterpillar before we had finished the Fiveless puzzles. So we have uh, So we have 4 5-list puzzles to go. So the hope is that we can finish the 4 5-list puzzles today. If we can do that, I will be a happy Zeta. Uh, the next challenge I have promised will be explicitly allow none Sudoku puzzles. So I think the next challenge probably won't mention fives. Uh, but maybe at some point in the future there will be a challenge with lots of fives. In the same sense that maybe at some point in the future, I will do that last puzzle from Caterpillar that I didn't do. Uh, so, uh, so we have to start with. I should announce, by the way, if you did not see Jessica and Ranksk and I set the puzzle Streamlined live on Ranksk's channel, we are very soon going to be posting to the channel an edited version of that to this channel. So if you want to see Ranksk and I and Jessica, all of whom are regulars in the chat that you can wave to, if you want to see us all set a puzzle that I think ended up being a pretty cool puzzle, you can look out for that coming up in your queue from this channel in the near future, probably tomorrow. We will see exactly when it is. But anyway, that should be fun. There'll be a link to the puzzle, so if you want to do the puzzle before you watch us set it, you'll be able to do that. If you just want to watch us set it, that will also work. And this will be, I think the setting process itself was about 4 hours. I think the edited version is going to be about half that. So if you want to see it, or if you saw it and you want to see it again, by all means, there it is. I know that actually if I look through like what people have watched the most of on this channel, the most popular stuff is actually stuff related to setting. So if there are things you want to see with relation to setting, I'd be very interested to hear it. So if you just want videos of just me setting puzzles, I can probably do that. I've contemplated doing streams of me setting puzzles, although I worry it would be incredibly boring. But edited videos of that's a possibility. Whatever, if there's stuff related to setting that you'd like us to do on the channel, I am very happy to consider it because, well, I like setting. Setting is fun, but it's not immediately clear to me what sorts of content related to setting people will eat up. So let us know. All right, so let's start with Nebuzaradan's 5 and Friends Gone Fishing. So this is a 6x6 Sudoku that uses the digits 1 through 9. Each of the digits 1 through 9 appear at most once in every row, column, and box. And 3 of those digits don't appear at all. And one of the digits that does not appear at all, as you might expect, is 5. So what we have here is we have what Sam Kappelman-Lyons always refers to as a mean mini, which is we have a 6x6 Sudoku that uses 6 digits, but we have to decide what the 6 digits are. So before we can really do anything, we have to decide what the 6 digits are. Cells separated by a black circle contain digits in either a ratio of 1 to 2 or 1 to 3. So black dots are not conventional black dots. They just mean that there is a ratio of either, again, 1 to 2 or 1 to 3 between them. And so we also have a negative constraint. So if there's not a black dot between two numbers, then there is not a ratio of either 1 to 2 or 1 to 3 between those. Yeah, it should be mentioned, by the way, I already do have multiple videos about setting. So I have a video of me setting the usual suspects, which is, I think, one of the best puzzles I've ever set. And I set it over the course of 3 days, I think. So was a total of something like 12 hours of setting, and it's edited down into a more consumable 2-hour format for you. So with lots of sort of my thinking, and you can see how much sort of forwards and backwards and trying things and all that kind of thing. I think that gives you a pretty clear insight. The key for that puzzle was I had enough of an idea what I was going to do going into it that I was pretty sure I could set it in a day, and then it took 3 days, but it still only took 3 days, which is better than a lot of puzzles that I end up setting, which end up taking a lot longer than that. I have on the Cracking the Cryptic channel, I have a video which is just my like how to set a puzzle video, and explains sort of my philosophy, some of which has evolved. I could probably do a follow-up on what has changed in my mind about setting since I wrote that video. And then that video also, I should note, features wonderful animations from my loving husband, who is wonderful. And then, of course, we have the one posted tomorrow, which will be that as well. So there are multiple options available, but I can always make more. I like Logan's suggestion of maybe a video on what I would consider common mistakes and how to avoid them. That's an interesting idea. The difficulty is really hard to do without examples, and I don't want to nitpick anyone. Okay, so here's a call out. Okay. If you're now someone who considers yourself an experienced setter, and you have puzzles from your early setting that you consider to be examples of common setting mistakes that you would not mind me talking about as examples of common setting mistakes, please send them to me, because I don't want to pick on anyone's puzzle without them saying, yeah, I know, and letting me do it. So if you have some examples, I'd be happy to do those, but I don't want to I don't want to pick random people or pick random novice setters to make fun of. And I also want to make sure that I'm accounting for taste. So I have a pretty specific sense of my own taste, as you've probably noticed, what sorts of things I like in puzzles, what sorts of things I don't like in puzzles. But it's really hard to draw the line between like what is a matter of taste and what is just bad practice. So I think having other setters sort of volunteer things is a good idea for that. So anyway, you can ping me on Discord if you have some examples of things where you're like, yeah, I used to do it this way, but I don't do this anymore. That kind of thing. I'd be interested to see it. Okay. Last up in the rule set, I know I am jumping around a bit, as Zetas are wont to do. We have palindromes, which means that these things read the same forwards and backwards. So those are the same digit. And these are the same digit. And these are the same digit. And I don't know if this is green or not, so I'm not going to color it. But I do know that these ones that I've colored, all of being a palindrome means is that they read the same forwards and backwards. And that is how that works. Okay. So the first thing I notice is that we have a string of 5 digits here that are separated by black dots. And I really want to say I like the way that this palindrome was used to tell us that actually this really is 5 different digits and not 4. Because you might be inclined to think, oh, this is going to be 4 digits at first, except you see the green digit appears in this box. So actually all 5 of these, or all 5 of these, however you want to look at it, are 5 different digits. Okay. And so let's just take a moment to digest what are the what are the digits that can appear on black dots? 1 could, 2 could, oh, I should turn my keypad on or it will not work. 1 can, 2 can, 3 can, 4 can, 5 is not even a thing, 6, 8, and 9 can. So it is only 5 and 7, unfortunately, that cannot possibly appear on dots. And this is, unfortunately, 7 different digits that theoretically could appear on these dots. And so, again, these are non-standard black dots, and so I'm allowed to do things like 1 to 2 to 6 to whatever to sort of get through this. So I'm not sure that I could argue what these are. Let's see, Russ thinks it has to be 1 that's living in the corner. So could we use 6 as a switching over point? Yeah, I like Sarvesh's point was where my mind was drifting as I think about what's going to happen. Is that this has to be 6-8, because that's the only way to make 14 without using a double 7. And so that tells us that there's a 3-4 in here. So 3, 4, 6, and 8 are all numbers that have to appear in this puzzle. Hey, Panthera. Okay, so yeah, the 6 lets you sort of connect to 2 different places. 6 could be with 2. Oh, no, 6 could be with 2. Thank you. Never mind. I retract my claim that all of these had to be in there. 6 could be with 2, because these are not standard Kropke dots. I might remember that someday. We will see. Now, I think maybe a smart thing to do would be to do some Sudoku, because I'm realizing I can place blue. Blue has to go here, because blue is not green, because they're in the same column. So maybe actually, rather than thinking about numbers, I should think about colors. And see if we can do more placing. So I also, because of this palindrome, I can't place blue here. So actually blue gets placed up there. And now blue is now in one of these 2 cells down here, and it's in one of these 2 cells down here. Now, is it possible that blue is both 2 steps away from green and 1 step away from green? In other words, is there any universe where this cell is blue? And I contend there is no universe where this cell is blue. And the reason for that is because in order to get from blue to green, I either multiply by 2 or divide by 2, and then either multiply by 2 or divide by 2. So there's a few possibilities there. One is, well, actually, there's not that many possibilities because we know blue and green are different. But in particular, it's never possible that the net effect of multiplying and dividing by 2 or 3 twice is the same as multiplying or dividing by 2 once. So blue can't go here. Blue has to actually go here, and so blue goes here, and we've placed all the blues. So the ratio of blue to green is either 4 or 6 or 9. We can at least say that much. I know that's not the most... I know that's not the deepest deduction that has ever been made by humankind. Let's see. Now, could I do anything more with green that is useful? Green has to be from 2, 3, 4, 6, 8. That's worth pointing out. Green now is one of these 2 cells. So green is 2, 3, 4, 6, 8. So green is one of these. Josh and Chili, both explain that as I try and break my desk. I should probably scoot closer rather than breaking my desk. That will probably be a good idea. Zeta scoot, as they say. Let's see. So, and it is even possible, actually. I said the ratio here is 6 or 4, but that's not even true. The ratio here actually could even be something like 2 to 3 or 3 to 2 as a ratio. Like this could be 6 and this could be 4 if I divide by 3 and then multiply by 2. So box 5 says SPQ can't have a 9 anywhere on the dots, because if there was a 9 anywhere on the dots, it would make blue 6. Oh, negative constraint. I completely forgot that there was a negative constraint, but it's true. Alima has a good point. There is a negative constraint, and so where does red go over in this box? Red in this box has to go here, because we know that... sorry. That would have been a way, way, way easier argument, by the way, that blue had to go here and not here, because I know there's not a dot between blue and green. And since there's not a dot between blue and green, I couldn't put blue here. That would have been nice. Okay, so, right. Sorry, box 5. I went to the wrong box. Red, we know, does not have a dot with blue because all dots are given. So red down here can't go any of these places. So this cell is red, which means this cell is red. Oops. I don't know why I put a yellow in there. So now one of these two is red. Let's see. Is there any universe where these two aren't the same digit? I'm afraid that maybe it's possible that these aren't the same digit. Annoyingly. Okay. So this cell, I haven't colored it yet, but I'm going to color it because I know that this cell is connected to both blue and green. And so that lets me place it in this box by the negative constraint. It has to go there. And so now, actually, if I look at this box, it now can't go there because it is connected to blue, so it has to go there. And now in this box, it can't go here because it is connected to blue, so it has to go there. And now it has to go here. And so that lets us place it there. So yellow is definitely 6 or 8. That is exciting. Okay. And so now because of that, this cell now is green. Now, where does green go in this box? Green can only now go here. And so hence green gets reflected over the other side of the palindrome, and green goes here just to finish up the greens. And so green is now 2, 3, or 4, not 6 or 8. Okay. So let's try to ambitiously finish the coloring if we can. Yeah, whatever this digit is, we're going to make this purple. Purple is just immediately placed in this box. Now, purple has a dot with blue. So when I ask where purple goes in this box, it cannot go here and it cannot go here. So purple of necessity goes there. Purple still has a dot with blue, so purple can't go here. Purple can only go here. I fear you may have lost me to coloring, because coloring is fun. Okay. We've now finished the purples. And so now we're going to try and figure out where this digit goes in each box. Except this digit is, of course, the same as... wait. I'm missing a color. What color have I not? I have not yet figured out what to do with red. Oh, only through lack of effort. I have not placed red here, which I can, so that means red is here. And so now there's just one more flavor of cell that is left to think about. Okay, so blue is now, by the way, 2, 3, 4. 2, 3, 4. So this is not 1, 6, 8, or 9. This is 2, 3, or 4. Oh, and the other cell I know is 6 or 8. Let's see if I can find a color to make this remaining thing. Let's see. Is orange horrible? It's not great, I'm going to be honest. We'll go with gray. Okay, so gray is 6 or 8. Oops, center is 6 or 8. Okay, and this is only 6 or 8. Alima suggesting the color of white. Okay, so now nothing else is 6 or 8 because gray and yellow are 6 and 8. But that is not immediately useful. Okay, so now the question is, does orange have to be 7? Sorry, does red have to be 7? Because if red actually shows up next to everything without ever having a black dot, then red can only be 7. So red shows up next to both 6 and 8. So there's red next to 6. There's red next to 8. So red can't be in a black dot relationship with 6 or 8. Here is red next to green, red next to blue, and red next to... Oh, do we only have 2, 2, 3, 4s? Oh, purple. Oh, but I don't see... Oh, there's red next to purple. Purple is 2, 3, 4. I just didn't mark it. So center 2, 3, 4. This is only 2, 3, 4. Okay, so red is now next to 2, 3, 4, 2, 3, 4, 2, 3, 4. Therefore, red is 7. So we have our first digit. Red is 7. Haha. Okay. Now, through coloring alone, we have gotten that red is 7. Okay. So now we have to look at what is going on with the rest of the world. Okay, so chat has figured out what's going on with the rest of the world as I have gone about my coloring. So chat is wanting to look at what happens between these digits. So how do I get from 6 to 8 in 2 steps? So I have to divide by 2, and then... Oh, no, here's a much easier question. Here's a much easier way to do this. Yellow connects to 2 different 2, 3, 4s. So yellow can't be 8. Yellow has to be 6. So yellow is 6 because only 6 of 6 and 8 connects to 2, 2, 3, 4s. I'm assuming that's equivalent to how chat was doing it, but it's not how I saw it. So gray is 8. Blue is 3. Uh-oh. Did I break it? What did I do wrong? Because this does not look good. Now I broke it. Blue is not 3. Oh, because 6 doesn't only connect to... 6 doesn't only connect to 3. But gray is 8. 8 does only connect to 4. And so now the question is, what number connects to both 6 and 4? And the answer is 2. And so now, what digit that's not 2 connects to 6? And the answer is 3. And now I think we have the puzzle. that was a really neat puzzle. I really liked that way that sort of like you have to color the whole grid before you can discover what's going on with the arithmetic of everything, or maybe I should say, rather than you have to, you get to color the whole grid before you have to think about what the digits actually are, and then everything just sort of falls in your lap, and that's very nice. I really liked the way, at least, that things finally got disambiguated for me, which is to observe that yellow had black dots with 2 different digits. Which I guess I could have done from this column alone. I did it more remotely by looking at those 2, and therefore yellow couldn't be 8, and that finally sort of collapsed everything. Very cool. Alrighty. Next up, we have the puzzle Shh by a friend of the channel, Scott Strosahl, who's part of the puzzle circle. So you can see on this channel, you can see a video of Tristan and I doing a puzzle that Scott made for us. On Scott's channel, you can see a video of Scott doing a puzzle that I made for him. And so there have been various sorts of things. Of course, now Scott is internet famous, so he may no longer be our friend. We'll see, but anyway, you can be his. You might be able to be his millionth subscriber if you go rush over there right now. So I'm very happy that he's taken off. So yes, like and subscribe this. Like and subscribe to Scott's channel. Let's see what Scott made for us. Can you post a link to Scott's channel, by the way, in the chat, Tristan? Okay, so we've got standard 8x8 Sudoku rules. Yes, I knew Scott before he was a Wordle superstar. That is true. That is true. Yes, you should like and subscribe to Rank's channel as well. Not because this is Rank's puzzle, but just because Rank's is cool. Okay, we've got standard 8x8 using the digits 1 through 4 and 6 through 9. Standard German whisper rules, which are that adjacent digits have to be at least 5 apart. By the way, actually, the very first Fiveless puzzle we did was by Rankskin Jessica. So if you want to go back 4 streams, you can watch the Ranks Jessica combo Fiveless puzzle that kicked us all off. And so, yeah, so the digits must be at least 5 apart, and then we have cages, and then the only stipulation on the cages is that they can't sum to 5. Okay, so as Russ suggests, we're going to start by parity coloring, and so the trick here is that on any German whisper line, there's always an alternation between high and low digits, where by high digits, we mean digits that are, oops, I did that badly. Is that right? Let's try this and see if we like it. There's always an alternation back and forth between digits that are high and digits that are low, in the sense of high is 6, 7, 8, 9. Low is 1, 2, 3, 4. Okay, so we're going to, yellow, I don't know whether yellow is high or low, but either every single yellow digit is from 1, 2, 3, 4, or every single yellow digit is from 6, 7, 8, 9. That is my claim based on what I am coloring. Bam. Okay, so there's our start. Someone will tell me where I screwed up the coloring, but because it ended up working around the edge, I have to have screwed up the coloring an even number of times. By the way, to Nee's point about why rules use may instead of should, I think if you say you should not do something, it's like a polite suggestion. Whereas if you say you may not do something, it's an absolute. So I think rules will tend to go for the absolute thing, whereas I'd use should to say, like, you should consider coloring for this puzzle. Okay. Oh, well, we do have letters if we want to use letters. At least we theoretically do. Enable letter tool on. Okay. So do we see any places where we have all of the purples or all of the yellows? And I think we do not. Okay. So I want to ask where 4 and 6 go in this row. I think that's a good question always to ask about whispered lines. So the thing about 4 and 6 is that if I made this a 4, say, then it would require making both of these digits a 9 because the only digit that's 5 away from 4 is 9. Hey, Chip, welcome. And so that's not going to work because I can't put 2 9s in the row in this puzzle, although that's becoming true of a smaller and smaller number of puzzles on my channel every day. The same is true of that one, that one, that one, that one, that one. And so that tells us that these two are a 4-6 pair. And also that these two are a 4-6 pair by exactly the same reasoning. And now that tells us that all of these cells are a 1 or a 9. In order that we get to continue that trend. Okay, so there's actually 2 sort of options for this cell. But in this row, actually, things are now continue to be forced. And the reason for that is that I still need to get 2 8 and 3 7 here. And so I think the easiest way for me to do this is to write this in above it. So let's imagine we start with 4 and then go to 9. And then we're going to end with 6 with a 1 before it. Nominally, I could make this either 2 or 3. And I could make this either 7 or 8. And then this could be... the other 2. So 7 or 8, and this could be 2 or 3. Okay. And so it looks like I have some optionality. But actually, if you look here, we actually don't have any optionality at all. Because this digit is next to both a 7 and an 8. And so this digit can't be a 3 because 3 can't go next to 7. So that's actually a 2. That's actually a 3. Now, 3 can't go next to 7. 3 only goes next to 8. And so actually, whenever you have a row of 8 consecutive digits that all see each other on a whisper line, there's only 2 ways to fill it in. The way that you get by reading this line forwards and the way you get by reading this line backwards. And so the upshot of that is that I get to fill in the rest of this line like that. Okay. And this is something you'll see come up over and over and over again in whisper puzzles that you end up with. Is that you'll end up with 8 consecutive digits on a whisper line, and then there's only one way to fill it in. And the reason why that sort of thing is helpful is now we know what these 2 digits are. Namely, these 2 digits have to be either... Well, let's look at this one first. This digit can only be purple 1 9 or purple 2 8, except it can't be purple 1 9, so it is purple 2 8. And likewise, this is yellow 2 8. Yeah, and of course, as Chad is pointing out, I can just copy everything verbatim to row whatever number this is, row 7. Okay. And so now I can also say, okay, so this connects to a 3 7. It's not a 1 9, so it's a 2 8. This connects to a 3 7. It's not a 1 9, so it's a 2 8. And now, what do we do? Boku to X-Wing is correct. Yes, we've now got a million digits that we have filled in. So purple 4-6, interestingly, is none of these cells. None of these cells can be purple 4-6. And so the purple 4-6 actually is elsewhere in the row. And so this cell in particular, it can actually only be 1 or 9, because it can't be 4 or 6, 2 or 8, or 3 or 7. And now this can't be, I guess the only thing I know is that one can't be 1 or 9, but I'm presuming I'm going to get the same thing here, where this is a yellow that's not 4 or 6, and it's not 2 or 8 or 3 or 7, so that's a yellow 1-9. This is a purple 1-9, that's a yellow 1-9. Did I fill those all in the right places? I hope so. And so now, and I think this is where these puzzles are super fun, is where we get to now play Sudoku on the yellow 1-9. And so where does yellow 1-9 go in column 4? Yellow 1-9 has to go here. And likewise, we can do the same thing with purple 1-9. Purple 1-9 has to go here. Oh, I'm glad you're learning tricks, Geneve. Welcome, by the way. Yeah, these are pretty good tricks for Whisper puzzles to know. Row 5, column 4 also sees purple 2-8. Oh, wow. Okay, so right. So this cell, thank you, Tom. Good point. This cell is not purple 4-6 because that's not far enough away from yellow 2-8. And it's also not purple 1-9 or purple 2-8, so it has to be purple 3-7. Which now means this cell has to be purple 2-8. And we can now play the same game over here, I bet. So this is... okay, what do I want to say this is? I want to say that this is purple 3-7. Because it sees purple 2-8 and purple 1-9 and can't be purple 4-6. So this is purple 3-7. And now this is going to have to be yellow 3-7. This is going to have to be yellow 3-7. It's going to disambiguate high and low by putting the yellow 2-8 next to the yellow 3-7, and then you're going to know that yellow is high because otherwise they would sum to 5. That is how this is going to disambiguate parity, or the other way around. Maybe this is a purple 4-6. That is my prediction. So this can only be 2-8 now. It sees every other yellow possibility. Likewise, this can only be 2-8. It sees every other yellow possibility. This can only be 2-8. It sees every other purple possibility. Oh, I can already place the yellow 3-7 in the cage? Oh, gorgeous. Yep, Sudoku places the yellow 3-7 in the cage. Beautiful. So there we go. So just to avoid pain for everyone, we now know that if yellow were low, this would be 2 plus 3 is 5, and that would break because the rules specifically say I can't make cages that sum to 5. So that's an 8 and that's a 7. And in fact, we can go ahead and do all the yellow 2-8s. They're all going to be 8. And therefore, all of the yellow 3-7s are 7. I thought I had more of them than that. Maybe not. The yellow 4-6s are 6. Now, purple 1-9s are 1. Purple 2-8s are 2. Are 2. Try again. Purple 3-7s are 3. And purple 4-6s are 4. Oh, sorry, I missed that. That was a 2. Purple 4 6s are 4, and I missed a couple random yellow 1 9s. More than a couple. I missed all the yellow 1 9s. Okay, and so now we are meant to ask where purple 4 goes in this box, or just 4 as it is known to its friends. And so the point is 4 cannot go here anymore, so this is a 4. Wow, I can't do digits anymore. So that's the whole joke of the puzzle, which is very cool. I like that a lot, that immediately gives me that the 4 goes here. So the 4 goes here. And so now I have everything in this box except one cell, which has to be the missing yellow. The missing yellow is 6. And so let's do a coloring expedition. So now this row needs the purple, and in fact it's the purple 4, we even know. Now the purple 4 is placed here to do that. Okay, the purple 4 now is placed up here. Purple 4, purple 4, purple 4 is placed down here. Let's see. So we've got all the purples in this column, so these 2 are yellow. I'm now only trying to minimize number of times I have to switch modes, rather than trying to minimize or maximize the amount I can deduce. These are yellow because of the box. This column has all the purples, so that's yellow. Let's see. Do I have any other places where that is true? This cell sees all of the purples, so it's yellow. Now this box has all its yellows, so these 2 are purple. This column has all of its purples, so that's yellow. This box has all of its yellows, so that's purple. This column has all of its purples, so that's yellow. The box has all of its yellows, so that's purple. This column needs a yellow in order to finish. Let's see. This cell must be the purple 2, so it's purple. So that's yellow. This column needs a purple. And so now this column needs a yellow. Okay, so now we're done coloring. Now we can just fill in the digits. So the remaining yellow in this column is 8. Oh, awesome, Sam. Congratulations. Well deserved on that puzzle getting rated a 100%. Okay, so that's a 6. That's a 9. So that's an 8. Let's see. That's a 6. So that's a 7. That's a 6. That's a 6. That's a 7. That's a 3. That's a 3. That's a 2. That's a 3. Okay, that's a 1. That's a 2, and that's a 3. And I think that's the puzzle. Very nice puzzle, Scott. I liked that one a lot. And it was also fairly quick. But I think this is a great puzzle, actually, as an introduction to Whispers puzzles where you have to do all the logic without knowing which parody you're on. So the way that through almost all of the puzzle, we had the purple 1-9, the yellow 2-8, and all of that kind of thing. That's something that comes up a lot in, say, medium-high difficulty Whisper puzzles. So it's a thing you have to sort of get used to wrapping your brain around, sort of like thinking of yellow 3-7 as a distinct entity. And I think this puzzle is a really gentle introduction to that, while still being super interesting and having this super, super cool way of disambiguating which is high and which is low. So this is the second puzzle, actually, out of this series that's had a really novel way of disambiguating between high and low. Because Nevario also had a different way you should go if you have not seen Nevario's puzzle from this list. It's called The Secret Need Not Apply. Nevario's puzzle also has just an absolutely beautiful sort of penny drop moment when you figure out that which is low and which is high and how it's disambiguated in the grid. All right, really nice puzzle. Alrighty. I see Panthera in chat, so let's go ahead and do Panthera's puzzle next. So Panthera here has given us a Japanese sums puzzle called No Fives Allowed. So therefore, I predict the picture is going to be a 5. It's going to look like that. That's my guess. We have alternating Japanese sums rules. So numbers outside the grid, some consecutive shaded or unshaded cells between groups of shaded cells must be unshaded cells. Okay, why is that alternating? Oh, because it's shaded or unshaded, but we don't know which is which. Okay. For odd rows and columns, the numbers outside the grid are for shaded cells, and for even rows and columns, the digits are for unshaded. Okay. So, oh, I might have to lower the puzzle a smidge. Let's see. There we go. I don't think I broke the world. Can you now see all of the top clues clearly at the top? Okay, so we're summing all the consecutive strings either of shaded or unshaded stuff. And so for our purposes, shaded is going to be purple, and unshaded is going to be gray. So this row has a 0 clue, which is very helpful. And so this is an even numbered row. And so this is an even numbered row. By the way, this is fiveless because there are no 5s anywhere in the clues. We do actually have to put the behated digit into the grid, but Panthera has arranged, and I imagine this is quite difficult, to make it so that not a single one of these clues involves a 5. Okay, so row 8. 8 is an even number, which means that this is giving me the sum of unshaded digits. There is a run of unshaded digits that sum to 0. And what that means is every single cell in this row is shaded. So we're learning that our 5 is going to look like this more. Something like that, I think. Okay, so all of these are shaded. Awesome, Alex. Did you enjoy Space Between Worlds? That is my favorite book in a long, long time. So anytime you have one of these giant clues like this 43, that is a very important thing to note, because that means this is talking about a string of, and so odds, it's talking about shaded cells again. So this is the top of our 5, remember? And so the shaded cells here have a string of cells summing to 43. Oh, I have not put a bet cell down. You are the first to ask for the bet cell, but ask and you shall receive. Any suggestions on a bet cell, Panthera, or I will make one up. But that means the only unshaded cell in this row is a 2, and it has to be on one of the sides. So all of these cells are definitely shaded. Betting purple is a good idea. Just make one up. Let's pick that cell. All right. Now, this column, the unshaded cells sum to 1 and form one contiguous group. And so all of these, sorry, not that one, all of these are shaded. This cell is officially unshaded and therefore is a 1. Now, in this row, the shaded cells sum to 41, so we're actually going to get this is a 3, and these are all shaded. And we have a digit dance. This is a nice, gentle start. Oh, did Tristan not post a link? Let's see. Give me 1 second, and I'll dig up a link for you. 1 moment. Be right back. Sorry about that. Did I do something wrong? Oh, oops. Wrong puzzle. Wrong puzzle. Right puzzle. Did I do something wrong? I did something very wrong. Yes. Wait, no. Nope. I think it's right because this is saying the sum of the unshaded cells is 1. Okay, let's go back. What did I have? I had this. The unshaded... Oh, I see, because the unshaded cell could be anywhere in here. Okay, I agree. Yeah, I do not actually know that, because no matter where I put the 1, it will form a contiguous thing. I just know these two cells aren't 1. Got it. Okay. Row 5, I can do the same thing. Those are shaded. 38 is big enough that we can... actually, let's do 41 first. 41 could have up to this much unshaded on either side. So these are all shaded. 38, no, wrong again. What did I do wrong? This is odd. Okay, 38 could have up to 3 outies. So these are, sorry, 38 could have up to 3 outies on the, but 38 is in an even row. So these are all unshaded, is what we have learned. Actually, let me make unshaded a bit bolder of a gray. These are unshaded. All right, so... oh, sorry. Here we're having... okay. Here our unshaded cells come in 2 groups that sum to 8. Let's see. So the 33 and 9, I admit this is one of the ones I really dislike thinking about. Okay, so the 9 needs to take at least, so the 9 is counting shaded cells, so I want to count from the bottom. So the 9 plus the blank have to take up at least this many cells, because there's no way I can hide the 9 entirely below this shaded cell. So this shaded cell has to be part of the 9. And so these are here. There has to be a gap. And so then that means I have to fit a 33 clue into this strip of 6 cells. And because of that, the smallest number of digits that I can add in order to get to 33 is 5 digits. 9876 is 4 digits. That's only 30. It's not enough. And so what that means is all of these cells are shaded. You can see our 5 coming in. Shouldn't the purples in row 8 be unshaded? In row 8, the shaded cells... sorry, in row 8, the unshaded cells sum to 0. So that means every cell is shaded. Okay, so now... I was going to do the 6s first, but now there's lots of cleanup because that does lots of damage. So row 3 here, there's one contiguous string of digits that sum to 6. That one's shaded. It could go as far as here, but we now know all of these are definitely unshaded. This row, I don't get anything. This row, we now know that this cell's unshaded and is a 1, as people in chat are excited about. So if you bet 1, then you have been rewarded judiciously. Now, in this column, I need the shaded cells to sum to 21. I can't make 21 in one cell. Oh, in fact, actually, I only have one string of shaded cells in this whole column, so those are definitely not shaded. I can't get to 21 in 2 cells, so that has to be shaded. That's right, we should dance for our 1. We are happy with the ones that we are given. So if you wisely bet 1, you are in good shape. Okay, the unshaded cells in row 4, they form one contiguous group that sums to 14. And so that could be, it has to be at least 2 cells. It could be as many as 4 cells, but it can't be 5, so all of these have to be shaded. This is an odd numbered row, and so I'm counting shaded cells. They make up a sum of 11 starting over here, so at least that cell has to be shaded. Column 8 now, the unshaded cells form one contiguous group, so these have to be shaded just because of the row logic. Oh, and in fact, it sums to 18. You can't get to 18 in 2 cells, so that has to be unshaded for the column. Let's see. Oh, this column is unfortunately even. Oh, okay, actually, this is still good. This column is even, so I'm counting the unshadeds. So the first group of unshadeds sums to 1. And I know this is the first group of unshadeds, so it's a 1, and these 2 are shaded. And then if I continue downward, the second group of unshadeds in this column sums to 12, so that has to be unshaded because I can't get to 12 in 1. In column 5, I need to get to 16 in my shadeds for the first gap, so in fact, 16 I can only do in 2 cells, and it has to be 7, 9. I'm now doing 7 in 2 cells. That's fine. And now I'm doing 3 in at least 2 cells. So this has to be a 1, 2. And so that now actually, that 1, 2 tells us what the 7 looks like. Namely, it tells us the 7 has to be a 3, 4. 3, 4. Because now I've removed the other ways of making 7 in 2. Okay, here I have 2 groups of gray. The 2 groups of gray have to add up to 8 each. That's not telling us anything. Here my shadeds need to add up to, they need to come in 3 clumps, and they need to add up to 4, 13, and 7. That doesn't tell me anything. Here, the only unshaded cell in this row is a 1, so this cell can't be the unshaded cell. Because there's a 1 looking at it. So this cell is shaded because it's not unshaded. Okay, here we have a 33 and a 9. I don't know what to do with that yet. This row now has 1 contiguous string of shaded cells. So that sum to 43. So the unshaded cell is a 2. And this is purple. Uh-oh, am I dropping frames? It doesn't look like it. Am I really frozen? I mean, I'm doing lots of things. Chat is unhappy I'm doing the things in a different order than chat would do the things. But that's okay. 7 here, this column needs shaded cells. The shaded cells need to add to 14, so that needs to be shaded. All right. Right. This can't be purple anymore because I'm now doing, remember, my shaded cells add up to 6. So in fact, this is unshaded, and these are a 2, 4. I mean, you have to be systematic about it, don't you? I mean, apparently you don't have to be systematic about it. But I do suppose I am the lawful evil rated setter, according to certain sources. So I suppose as the lawful one, I should be more the one who's doing it systematically. Okay. this row, I'm now seeing the 38 clue says the unshaded cells are contiguous, so this has to be shaded. And actually, the unshaded cells sum to 38, so I need a lot more of them. I need at least 5. Let's see, the outies. No, I need at least 6 in order to get to 38. So these are automatically shaded no matter how I do it. And that now has given me the unshaded cell in column 2. So it's the 1. The rest of column 2 is shaded. Of course it's a bold 5. How is it going to be anything other than a 5? Oh, here this row is also done. So the 6. Yours was actually scheduled for last. I only didn't do it last because I saw you were here, and I know you don't get to see the stream live super often. So I figured I would do it while you were here. Row 2, the unshaded cells form one contiguous group, so that adds to 6. So it's those, and these are shaded. Okay, so we are in pretty good shape. I do my best to be an accommodating sort of zeta. Okay, so let's look at this column. We have 1, 2, 3, 4. So we need a 5, a 6, and an 8 for the column to finish it. Let's see. Column 3, I am being told by certain sources, can be finished. Oh, yeah. Hey, how about that? The shaded cells at the top here sum to 4. So those are a 1 and a 3. And we actually even know the order because of the 1-5 pair over here. So these are a 3 and a 1. Now the 7 at the bottom no longer can be in 3 cells, because the only way to make 7 in 3 cells is with a 1, 2, 4, which I cannot do anymore because there's a 1 in the column. So this cell is unshaded. Now, how am I making 7 in 2 cells? Only as a 2, 5, once 1 and 3 are gone. Oh, someone has placed a 1 by Sudoku. That is exciting. I'm looking forward to that. Okay, so Alima, yes, Alima has found the 1 in box 5. I have to go there. That is exciting. I always like it when Sudoku manages to sneak into these things. So now I can ask how I'm making 13. So I'm not making it as 3 and 10. I could be making it as 4 and 9, not as 5 and 8, or it could be 6 and 7. So I actually don't know how I'm making that happen yet. This 38, the 1 here tells me that there's not a 1 in the outies. And so in order to have outies, that is things that were, in order to have shaded cells that summed to 7 and have 3 of them, I would need to have one of them be a 1. So the upshot is these are unshaded. Because I need them to be, and these two cells sum to 7. Okay. It is true one of these two cells has to be a 2. I think that's the X-wing that Nicholas is talking about. The shaded cells in this row come in 2 groups, so that can't be shaded. In this column, this group of cells sums to 8. So it has to be an 8, so that's not an 8. These 2 cells now need to sum to 8 without using a 1, so they're either 2, 6 or 3, 5, but I don't know which yet. Okay. 18, good. 21. Yeah, the question is, do these sum to... this 1 looks up. So that's a 5 and that's a 1. All right, so Yeah, these two need to add to 7, but I don't know which way they add to 7 yet. These two need to add to 12, but I don't know which way they add to 12 yet. These two need to add to 13, but I don't know what way they add to 13 yet. We've got our 6. Ah, there we go. The unshaded cells in this string sum to 18. So these need to be an 8 and a 9, and I know the order is the next of these deductions. Okay. So yeah, the 8 in this box has to go in one of these two cells. And because the 8 now has to go in one of these two cells, sorry, that's an 8. Because the 8 has to go in one of these two cells, that actually tells me that these have to be a 6-8 pair. Because if one of the digits is 8 and they add to 14, it has to be a 6-8 pair. So let's sum these. Let's see, 3, 4, 5, 6, 7. 3, 4, 7 to do the rest of these. Now, these aren't 4, so that is a 4, just by Sudoku. This is a 5 or a 6, just to finish the row. Now, I need to get my outies here to add to what? My outies in this column need to add to 24. So these cells add to 8. So I need these cells to add to 16. And the only way that this pair is going to add to 16 is with a 7 there and a 9 there. So that's a 3. Okay, so okay, so chat has lots of things. So 13, what did I do? Did I mess something up? Oh, the bottom could be part of the outies. That's right. Sorry, I don't know whether this is shaded or not. Good catch, good catch. Would have been nice if it worked out that way, but sadly it does not. Row 6 in box 6 is a 3, 4. Right. It's not 1, 6, and it's not 2, 5 because of the above. So these are a 3, 4, and I know the order. Good catch, Nicholas. Let's see. Row 7, column 1 is shaded. Right. I can't make a sum of 10 in 1, so this has to be shaded. Good catch to Ambrose. Okay. I guess the only way this cell is unshaded is if it's exactly a 3 by looking at this row. Yeah, so the 9, and these are going to sum to 9. Okay. Column 1 can't have just one outie. The outies need to sum to... right, because I can just think about what it is. What do the outies in column 1 sum to? Great point, Sarvesh. The outies in column 1 sum to 3. Well, if there were only one of them, this would be a 3, and it can't be. So that goes there. These two digits need to sum to 3, so therefore they have to be a 2 and a 1. That was a really good spot. So that's a 2 and that's a 1. That 2 looks over. That's a 5. That's a 2. That was a really good spot, Sarvesh. Okay, so we've got that, and as somehow Alima is already pointing out that this 5 looks up, even though I swear Alima typed that before the 5 was even in the grid. But that 5 does indeed look up, so that's a 6, that's a 5. These aren't 5 anymore. So here I need to make now these two cells sum to 13, and I now can't use the 5 anymore. So therefore, the only way to do that is with 4 and 9, because I can't use 5, 8. I can't use 6, 7. So these two cells are the remaining ones in the column. They are a 7 and an 8, just to finish the column. Let's see. Yeah, this would be a 6 if it finishes. So yeah, this cell can't be shaded now because the shaded cell, this cell can't be unshaded because the unshaded cells in this row sum to 14. That's already an 8. So if I made this unshaded, I would need these two to sum to 6, but the box actually breaks both ways that I could make 6 in 2 cells. So in fact, this is shaded, and that's a 6 to make the 14 work out. Probably a good point to notice that actually 1 is not the correct outie. So in row 9, thank you, Josh. That's a 3. In order to make this 41 clue add up, and that gives me a 7 and a 3 up here. What do my outies have to add to? I don't think 2 is enough. My outies in this column, let's see, it's 30. My outies have to add to 15. So yeah, I could only make there only be one outie here if this was a 12, which it can't be. So that's unshaded. These two cells need to add to 12 without being 3, 9 or 4, 8. So they have to be 5, 7 in order to make that work. If I did that math correctly, chat will tell me if I did that math horribly incorrectly. Which is the joy of having a chat watching. 2, 3, 4, 5, 6, 7, 8, 9 to finish off this box. Is my math correct? Outies are 13. No, my math is not correct. Sad. Okay, unshading dance. So... Oh, because those are 18. 9 and 9 is not 16. 9 and 9 is 18. So yeah, these sum to 32. My outies in the column... Sorry, that was right. And then something happened over here. This really is a 3. That part's still true. The outies are 13. So, sorry, the outies are 13. So my conclusion was right, but my math was wrong. The outies here are 13, and so I could not have just one of them. But in fact, actually, these two cells need to sum to 10, not to 12, which is what I was trying to make them sum to before. So good catch, Naverio. So now how am I making 12? Or sorry, how am I making 10 only as 1, 9, and only in that order, I believe. So now we can do these 3 digits. These 3 digits are a 2, 3, 4, 5, and 7. Let's see, there's all kinds of 1s looking up. People are telling me up. So the 4 1s look at box 9. I already have a 1 in box 9, unfortunately. I would love to place an extra 1 in box 9. These are an 8, 9 pair to finish the column. Let's see. Okay, so these need to sum to 12. Do I know how that's happening yet? Maddeningly, I think I don't. We're going to fill in this row. 3, 4, 5, 6, 7, 8. Oops. 5, 6, 7, 8 is what's left in this row. I don't think I know anything about that. Oh, well, let's see. I know some things. So these need to sum to 8. So they don't include an 8. They also don't include a 7, because if this were a 7, this would need to be a 1, and it can't be. In fact, actually, this can't be a 6 either, because then this would need to be a 2. So in fact, wow, I'm not typing well today. That's a 5 and that's a 3, so I actually get that. Let's see. So that finishes that column's clue. These two sum to 12, so they can never involve a 6. So this is either 5 with a 7 or 8 with a 4. Those are the only options for how I'm making this sum to 12. And then once I have that, I think I'm going to be done with the all the sum clues, right? I think so. Let's see. Yeah, we have this X-wing on 8s here between these. So there are 2 8s in these 2 rows, and they are in these 4 cells. So that's a 9. Good catch to Ben. That's a 9. That's an 8. So now, oh, never mind. Sorry, I was going to try and do more, but the more I was going to do was wrong. Let's see. So this column is missing a 2, 5, 7, and a 6 to finish the column. Hey, Franco. This is not a 2 or a 5, so this is definitely a 6 or a 7. That's not a 2. Alrighty. 7, 8 pair in row 6. 7, 8 pair in row 6 has appeared. So that's a 6, and that's an 8, and that's a 7, and that's an 8. And that's a 7. And then that's a 5. Okay. 5, 7. Oops. Not 5 or 7 anymore. Oh, are you saying you wouldn't call that an X-wing? Mr. Change one of those? Or Mrs. Change one of those? Sorry. Mr. or Mrs. or other. 2 in box 9. Yes, 2 in box 9. Good. That is a 2. So this is not a 2. Thank you to whoever... Not a 2. Wow, I can... It must have been all of those 6x6s that now I can't type anymore. We'll blame that. It is assuredly not that I've never been able to type digits correctly. Oh, yes, Torvald, you are successfully chatting. 3, 4, 5, 6, 7, 8, 9. It's also possible. Let's see. These are not 7. Always grape crystal light, Martin. Always grape crystal light. The refreshing taste to get you through the day or something. I still hope grape crystal light will sponsor me eventually. Oops, sorry. 2, 3, 4, 5, 6, 7, 8, 9. Okay, these are 2, 3. Okay, so these are not 2 or 4. So these are not 3 or 6. Do I have one of those looking up somewhere? Probably have one of those looking up somewhere. I don't seem to. Let's see. Yeah, you could definitely get a Soylent sponsorship. You definitely drink more Soylent than anyone else I know, I think. I think actually probably streaming decreases my grape crystal light intake. 3, 4, 5, 6, 7. Just because I think I drink less when I'm streaming, because I'm focused on other things. Pour 2, 4 in box 1. What did the... Oh, the 2, 4 in box 1. Oh, thank you. Thank you, Medi. So that's a 4. That's a 2. Okay. There was some discussion of what's happening with 4s somewhere at some point that maybe now would be a good time to figure out. In box 7. 8 in box 7. Yes, 8 in box 7. Good point, Martin. So there goes the 8. Yeah, one of my favorite facts is that there's this whole movie about Soylent Green, and it's this superfood that, of course, turns out to be made out of people, and it turns out it's based on a book. And in the book, it turns out it does not at all turn out that Soylent is made out of people, but the book is sort of a thinky piece about food in an ever-growing society that they decided for whatever reason to make a movie about, but they decided the movie was too bad or too boring for an actual movie. So then they just added this whole bit about Soylent Green being made out of people. But it's my understanding that the food Soylent is named after the book, not after the movie, where it is not, in fact, made out of people. So I think we are meant to believe that Ranksk is not eating people. But who can be sure? These aren't 5. Let's see. I mean, it depends on whether you're in the book or the movie. Okay, so those are 7, 8, 9. So that's 6. That's 8. I think it's probably good for your brand if you build mystery about whether you are eating people on stream or not. This is an 8, just by Sudoku stuff. We've got some 2 4s, some 7 9s going around. Oh, there's a deep, deep callback, Tall Cat, to a TV series from 20 years ago. Hey, Scott, you came just a smidge too late to see your puzzle, but we really enjoyed your puzzle, and the VOD will be there. There's an unfinished clue in column 7. Oh, thank you for pointing that out. There is an unfinished clue. These two need to add to 9. How are these two adding to 9? Well, let's see. Only is 4, 5, because 1, 2, and 3 are gone, and we actually even know the order of those. Thank you. That's always the hardest thing to spot when you have a secret hidden clue that you've not finished, and then it becomes very difficult to resolve the puzzle if you don't notice that you have a secret hidden clue. 6, 7 in column 8. For the record, I actually am old enough. I did watch Heroes. I did really enjoy the first season of Heroes. Okay, let's see. There's a 4 there, so these aren't 4 anymore. Let's see. There's an 8 in one of these 2 cells. I know which one. So 8 in box 5 gets placed here. Let's see. Column 1, row 8 is set by clues. Column 1... No, definitely not old enough to have watched Soylent Green when it was in theaters. I'm trying to think if I saw any Charlton Heston movies in theaters when they were first out. Not that I'm aware of. Yes, I see it now. Okay. In column 1, this is supposed to add to 9, and it can't add to 9 if I make this a 9. Good catch, Nicholas. So that's a 3, that's a 9, that's a 7, that's a 9, that's a 7. Remember earlier when I was being systematic about looking at clues? Somehow that fell away, possibly for the worse. That's a 5, that's a 9. These aren't 5 or 7. So that's a 3, and that's a 6. That 3 looks over and sees that's a 4, and that's a 3. The 4 looks back and sees that's a 9, and that's a 4. Oh, that was his last movie? I know he was doing a bunch of NRA stuff when I was a youth. Let's see. Okay, so these are a 2 and a 9. So that's the 9. That's the 2 for the box. If I did that correctly. I did not repeat a digit in this box, did I? That's my favorite trick, is to repeat a digit in a box. That's a 5. That's a 7. That 2 looks up and sees that's a 4, and that's a 2. That 3 says that's a 6, and that's a 3. These are not 6s. That 4 looks down and sees that that's a 6. That's a 7. That's a 6. That's a 4. That 6 says that's a 9. So that had better be a 7. Woo! And yes, as the pop-up suggests, this is the first time I've gotten a Cracking the Cryptic pop-up in a long time, because it turns out that you don't you don't get a Cracking the Cryptic pop-up if you do a puzzle without fives. But yes, you should definitely support Sven on Patreon if you are so inclined, because the Cracking the Cryptic app has been very useful for the community as a whole. So that means we have only one Fiveless puzzle left by ZegreS and JeremyDover, and we're going to do it when I get back from a very brief break. I'll be right back. Alrighty, we're back. I'd like to thank, by the way, thank you to all of those of you who support us on Patreon. We greatly appreciate it, which is why we have the Patreon thank you every time we go to break. So thank you very much. If you'd like to consider becoming a patron, you can go read more about it on patreon.com/zetamath. But we've been getting lots of support, and we very much appreciate that. Alrighty, let's look at this last puzzle. By the way, the Panthera puzzle was very nice. I quite enjoyed this. I have been enjoying these more accessible Panthera puzzles that I have been getting of late. Usually Panthera puzzles are too hard for me, but there have been some really nice ones lately, and this one is very nice, very accessible, I think. All right, so next up, Time to Think Outside the Box by ZegreS and JeremyDover. So let's read the rules carefully. So there's a secret mission behind each shape in these Sudoku boxes. The shape in box 5 is missing. Fill in the shape to start. Normal Sudoku rules apply. On gold entropic lines, every 3 adjacent digits consist of a low, a medium, and a high digit. Purple Renban lines connect a series of consecutive non-repeating digits. Determine the type of line in box 5, Renban or entropic. White dots white dots join consecutive digits. Black dots join digits with a 1 to 2. Oh, I guess this is not part of the Fiveless thing. Anyway, we're going to do the puzzle regardless, but I think it turns out perhaps I misunderstood or copied this from the wrong part of my thing or something. I need to scroll down slightly. Oh, I can push my camera back up. Okay, so I'm guessing this is like one of those IQ type things where I'm supposed to sort of figure out how we're getting these things. So is this like the top half of a clock or something? I think this is going to be the top half of a clock, because if the clock is on 1, then oh no, this is backwards from the top half of a clock, because that would make a 5, not a 2. But then that would make a 3. I guess if this were a 4, this would go. Okay, maybe this is nothing to do with the clock. Although now I'm seeing this. Oh, it's the bottom half. It's the bottom half. So that's the 2. That's the 3. That's the 4. That's the 6. The 7. The 8. And the 9. Yes. Okay. So it's the bottom half of. It's the bottom half, not the top half. I don't know how my brain went to that, but anyway. Alrighty, so enable pen tool so we can draw in the line. So the bottom part of a 5 would look like that. Would look like that. There we go. So there's our bottom half of the 5. Now, I mean, presumably it's a Renban, right? It doesn't actually say, but I mean, the pattern seems to be it alternates the whole way. So I assume that this is sorry, an entropic line. I assume this is an entropic line, just by that. Okay. Okay. Regular white dots, regular black dots. All right. So. And we know this is a high, a medium, a low. This is a high, a medium, a low. So that's already very interesting if you think about this. So if I've already used 2 highs, 2 mediums, and 2 lows in this column, that means that these 3 cells are a high, a medium, and a low that all have to live together in harmony on a length 5 Renban. Well, the lowest high I could take is a 7. And the highest low I could take is a 3, and 3 and 7 only just barely can live together on a length 5 Renban. So I actually know that this Renban is, I can fill it in, it is 3, 4, 5, 6, 7. I know these aren't the 3 and the 7, these are 4, 5, 6. I know this one's not the 7, of course, because it's on a black dot, and 7 doesn't go on black dots. And we probably need to start doing our coloring, because we actually now know that these are medium. So I think I'm going to do purple for medium, orange for high, and blue for low, is I think my coloring for this. Same logic on the other black dot. Well, I know that this is a 1 or a 9. Oh. Yes, good point. The other black dot is also a black dot. And so one of these is a 7, and it's only that one, and we get a digit. Woohoo! Haha. Yeah, and neither of these is a 5 either, by the same thing. So we get to color this orange. Again, my coloring here is 1, 2, 3 is blue, 4, 5, 6 is purple, 7, 8, 9 is orange. Okay. So that is orange. Now, this is a length 8 Renban, and so this digit here is a 1 or a 9, just because that's the way length 8 Renbans work. Likewise, this one here is a 1 or a 9. Let's see. what else can we make do with this? How sure are we, chat, that this is an entropic line and not a Renban? I think I'm pretty confident of it, but I don't 100% swear it. Okay, I do know that there's a 5 over in one of these cells. Okay, so I can say that I know that 5, 7, and 9 all exist off of these black dots. So I could, and I'm going to, pencil mark 5, 7, 9 in the corners of these cells, just so I sort of keep that in mind. And of course, these aren't the 7. So 7 actually is in one of these places. So if this is an entropic line, it's interesting because it needs to eat the last medium digit across the row. Because this will have a high, a medium, a low, and so there's only one medium left in the row, and so that would place a 3 here. So I feel pretty confident that this is supposed to be an entropic line. It would be very weird if it was not. So I'm going to assume that it is, and if it breaks, then we'll come back here and we'll figure out why we were supposed to know that it was a Renban. But that'll place a 3 here and a 6 here as soon as we do that, because, again, these 3 digits on an entropic line need to have a medium digit. So this is going to be blue, 6 is going to be purple. This digit here is now not a 3 or a 6, so it's a 4, apparently. Yeah, it's not 5 and it's not 6, so yeah, it is 4 as my medium-y number for the row. So those aren't 4, those are a 5, 6 pair. So these aren't 5. So this is a 2 or 8, just for the record. Let's see. And of course, I know that there is a high. Let's fill in box 4, suggests Barbie. Sure, we can do that. 3, 4, 5, 6, 7, 8, 9. 1, 2, 8, 9 to round out. And so the point is, wow, okay. Barbie with the slick spot. We've got a quad in row 5. And so the quad in row 5 now means that this isn't a 9. And in fact, we can fill in the rest of the digits. They are not 1, 2, 4, 8, or 9, which is to say that they are 3, 5, 6, and 7. And of course, these are not 5 or 7, so they are 3 and 6. So now these aren't 3 and 6 anymore. They are 5 and 7 to make the row go round. So yes, so, well, we already assumed it was entropic to get here, so we have not proven that it's not a Renban, because we assumed it was entropic in order to deduce this. So if we assume it's entropic, then it's not a Renban. But we used the fact that it was entropic to know that there was a middle digit over here, which then fixed this digit, which then fixed that digit, and so on and so forth through the ages, as they say. The quad didn't use the assumption of that. Yeah, it did, because I used the quad was necessary for me to get, or I needed this digit in order to get the quad, didn't I? Yeah, I needed all of these digits in order to get the quad, I think. Alrighty. I agree at this point, Nicholas, it's forced. But the question is, did we already use the assumption that it was entropic in order to get here? And the answer is yes. We very much already used the assumption that it was entropic to get here. Now, I assume we were supposed to. But, because, I mean, it would be very weird setting if you were supposed to deduce that this was supposed to be a Renban. But we certainly have not proven that this has no solutions if this is a Renban, as of now. Okay, so there's a 3 or a 6 there. Okay. So yeah, this has got one middle, one low, one high. It doesn't immediately tell me a lot about over here. So if we just like started over, Nicholas, are you asking where 1 and 9 go in box 5? Well, 9 would certainly have to go on here if it's a Renban. And then 1 could go in one of these 2 places, presumably, in that instance. But yeah, so the place we assumed it was entropic was to resolve this cluster. All right. But I mean, it's very possible that you could prove that this just can't be a Renban, but that's not what the puzzle suggests, or that's not what the instructions suggest. The instructions say figure out the pattern and fill it in, which we did. And then we sort of thought we knew what the pattern was, so we figured, okay, we'll go with that and see what happens. 4, 5, 6, 7. Oh, it's not a 6. Because that's a 6. Yeah, I think it made sense to assume, and if we broke it, then we'd go back and we'd figure out why we were supposed to know that this was a Renban, and then we'd have an aha moment, and it would be exciting. So that there was really no horrible risk. I think Nicholas is convinced that it can't be a Renban if we just reset the puzzle because of thinking about where 1 and 9 go in the box. But I'm not convinced that I couldn't hide a 1 over here somewhere. But anywho, what are we to do now? So the only way this can be high is if it's a 7. I mean, isn't the type part of the pattern? Let's see. Can I duplicate this? One moment. I'm gonna try and I'm gonna try and pull this up real quick. I'll be right back. All right, here's a blank version. We're going to try and go through Nicholas's argument here that once we know, because this will either be very cool or it won't work. Right-click on the tab to duplicate. I don't have a duplicate. Oh, I do have a duplicate. Okay. I will remember that for future. So the point is, I believe, that actually maybe so I believed before that 9 had to definitely go on this, but I don't think I even believe that necessarily. Yeah, so these are from. So if this was a Renban, these would have to be from 1, 2, 8, 9. That one wouldn't be a 9, of course, because you need all the other digits to have that work out. Row 5, column 8 can only be, yeah, this is only 1 or 9, just because it is. We already have that filled in on our other grid. Okay, so that's 3 1, 2, 8, 9s. Yeah, knowing that this is a 3, 4, 6, 7 didn't do anything, or did not use that. So sorry, 3, 4, 5, 6, 7. So this would need to be a 4, with that being an 8. So we'd have that. And now, got it. And now the point is that this is 1, 2, 8, 9 is just what happens to be left here. And now that's too many 1, 2, 8, 9s for the row. Okay, agree. So yeah, okay. So we have definitely proven this has no solutions if this is a Renban. And by we have proven, I mean chat has proven. I don't know that this was intended to be done, but cool argument. As a mathematician, my brain really does not like rules that don't tell you what the actual rules are. So like this kind of thing is very difficult for my brain to deal with, because it's sort of like, guess if you're doing what I'm guessing. It is just like my brain doesn't quite do it. But yeah, I really honestly I cannot even guess whether you're intended to make that argument or not. Oh, Sergey says it's intended. Is Sergey one of the setters? But anyway, it's a cool argument, so I like the way it was argued regardless. But yeah, I am very uncertain about what is intended here. Okay. Let's see. But it's now proven, so we can use it without shame. Oh, cool. Nice. So, yes. So, Setter confirms we were supposed to figure out that we were supposed to go through that argument. And it definitely works to show that. Okay. So, we now have to sort of keep picking this apart, though. Box 5 top dot is not 3, 6, says Barbie. Since one cell sees both a 3 and a 6. Good point. Okay. This is not 3, 6 because this cell sees both a 3 and a 6. That's a good point. So this is 1, 2, 4, 8. I can at least handle that. Now, this interplay, like, I love this break-in. This is so cool. I really like the interplay between these. I've not used entropic lines before or played with them, but the interplay between those and Renban is cool. So here's another point. Oh, no, sorry. This is not a Renban. We're back to the inverse where this is an entropic line, not a Renban. Should I count how many types of each digit there are on this line? Do I know? Can I figure that out? Because it's every 3 strings. So, like, whatever happens, these two are the same high-lowity, right? Because every string of 3 consecutive ones are the same high-lowity. So these two are the same high-lowity. Otherwise, it wouldn't work. Now, this one, interestingly, cannot be high. So this is not 7 or 9 in order to make that work. In order to make that possibly work. So this is only mid or low. So now these two are the same high-lowity. I don't know that that tells me a lot. These two are the same high-lowity. I also don't know if that tells me a lot. Oh, but these two are the same high-lowity. So that now tells me, that again tells me that this is not 9. So the 9 is actually in one of these two cells only. And the 7, annoyingly, can get in a couple places. I know one of these two is the last purple in row 4. How do I know which one it is, Ambrose? That's what that's what I was sort of hoping this story would figure out for me. Like, could this be, or do you just, when you say I know it, do you just mean I know it's a 4? So I know that one of these digits is a 4. Because I definitely agree. I know one of these digits is a 4. So I know this digit's not a 4, for example. Row 4, column 6 can't be... Oh, right. One of these two is 9. Got it. Okay, Sarvesh has it. That's the point. One of these two is 9. And so neither of them is 7, because I can't have 2 highs in this string. So this is not 7, which means this digit now has to be 7. I don't have anywhere else to put the 7. That's gorgeous. Okay, I really like that. That's a 5. So we can go ahead and say that's high, that's medium. Okay. I know there's a 7 up here somewhere. Yeah, that was really clever. Yeah, this is sweet. Okay, so let's see. So if I want to color, I can color that those two are the same and these two are the same. I'll use gray, I suppose, just to help visualize this. Oh, I now know one of these two is 5. Aha! One of these two is 5, and so this one's not medium. So this one can only be high or low, which means it's 1, 2, 3, or 8. It can't be other things. Because one of these two is medium. Because one of them's 5. If this were medium, it would be exactly a 4. Let's see. Ben says, think about where 8s live. So if 9 is here, 8 can go here. And if 9 is here, 8 can go here. And 8 can always go here, I think. So I think one of these 3 is always 8. Oh, I can't have 2 highs off of this, because if I just count, I have 3 yellows. Yellow is done. I have 2 greens and 2 grays. So these 2 are different colors. So this can't be an 8. Genius. So that's a 2. So these aren't 2. That's not 2, and that's not 2, which seems very relevant. So the low digits on here are a 1 and a 3. So yellow's not low, because all the yellow digits are on this line, and 2 isn't. So yellow's not low. So this digit's a 6. This digit's a 3. So yellow is purple, as Chad is discovering. This is an awesome string of logic. Let's see. So that's blue. Okay, so one of these 2 is a 5. It has to be the one that's the same color as the 6. So that's the 5. That's a 4. This isn't a 4 either. So this is a 1 or an 8. Let's see. Okay, so we've got our middles all worked out. One of these 2 is a 9. One of these 2 is an 8. And so because one of these 2 is an 8, I know that's not an 8. Just at least I know that much. Okay. Interesting. Okay. Barbie has a point that if I look in column 3 and ask where the 5 goes, the 5 has to go down here somewhere. I agree. Unfortunately, that doesn't even rule it out from here, but I agree that one of these is a 5. Row 3, column 5 is not 1. Right. Definitely not a 1 anymore. 1 doesn't connect to 1 or 8. This is a 2 or a 4. Let's see. So yeah, so these 2 need to be opposites. So yeah, one of them's an 8, and one of them is a 1 or a 3. I do not know which yet. 1, 2, 8, 9 on the outside in box 2. Yep, these are 1, 2, 8, 9, which I probably should write in because we've been having some luck with 1, 2, 8, 9s. It's not clear to me exactly how it's going to help. I know this one's not a 9 because I know one of those 2 is a 9. I know this one's not an 8 because I know one of those 2 is an 8. I've almost got there. I've got 3 1, 2, 8, 9s. So actually, that's 3 1, 2, 8, 9s. That tells me this cell's not 1, because if this cell was 1, it would give me 5 1, 2, 8, 9s in the column. Good. Okay, so this is not a 1. Okay. So this could still be an 8, or it could be a 3, which seems marginally more likely. Yeah, whichever of them is an 8 puts a 4. Did I do something wrong? Are people telling me to back up? I'm not quite sure what chat is telling me. Oh, chat is just telling me this can't be an 8. This is an 8. That's a 4. That's a 2. That's a 1. 6 is limited to row 6, column 7. Sorry, row 6, column 7. You run out of 1, 2, 9s. Okay, so the... Okay, so yeah, so instead of counting 1, 2, 8, 9, let's just count 1, 2, 9s. There's 2 1, 2, 9s. That means I could never use a 1, 2. Because if I use a 1, 2, I've now used 4 1, 2, 9s. So this is not a 1. So therefore it's an 8. I think I saw that backwards of the way that people in chat were describing it. But that works out. So that's a 9. This is the other low digit. That's a 1. So these are blue. These are orange. This is purple. This is purple. Okay. Got there. Okay, so this is not a 1. One of these is a 4. Yeah, good catch. Logan is seeing that one of these has to be an 8, so neither of these is an 8. And in fact, neither of these is a 9 either, so this is a 1, 2 pair. That's not a 1 either. So in fact, actually, that places the 1 back over here. So that's low. So very good catch to Logan there. These are now both high. These are both low. Yes. Ambrose says this can't be a 2, because if this is a 2, then that's an 8, which means that I have now taken both 2 and 8 off of this Renban, which means I'm going to have an awfully hard time making it work. So we're going to remove 2 from there. That's a good point. So now that is the 1 and the 9 for the column. So these are just whatever's left, which is to say they are a 2 and a 5 remain. So that's a 2, 5 pair for the column. Yeah, so we can fully pencil mark this box. 2, 3, 4, 5, 6, 7, 9, and 4, 6, 8. Let's see, if this were a 2, that would have to be a 1. Seems vaguely okay. This isn't a 4 anymore. This is a 5 or a 7. I'm noticing that this cell is not the middle cell. So one of these two has to be a middle digit. The only way this is a middle digit is if that's a 7 and this is a 6. Oh, this can't be a middle digit because it has to be a 5 and it can't be. The middle digit in these 3 is a 5, and the only place a 5 can go is here. So that's a 5. Sweet. Okay, so now I know, because that's medium, I know that this is also medium. So this is a 4 or a 6. Let's see. Am I going to have any luck sort of trying to leverage that? I know one of these two now is medium. I don't think I can do a lot with that yet. Okay, let's see. Nicholas's row 4, column 1 has to be a 6. Oh, yes. Good point, Nicholas. Only 6 is next to a 5 or a 7, so that's a 6 and that's a 5. One of these two I know is a 6. Column 9's middle digits must be high, medium, and low. Good point. Okay. As Barbie points out, I'm done with middles for column 9. This is exactly how we started the break-in, actually. And we could have done it here. In fact, actually, we really should have done it exactly here, exactly as soon as we started, because we know we have a high, medium, and a low in each of these 3 strings. So this also has to be a high, medium, and a low. And so in particular, this digit's not a 4 or a 6. It's an 8. And now once this digit's an 8, this digit's not a 7 or a 9, and it's a 2. That was very cool. I suspect that's something someone who had done these puzzles before would have seen immediately, that we did not see immediately. But works out. This digit now has to be an 8 because it can't be a 6. Very cool, though, that it works out that way. 5 in row 3 looks left. Agree. What was the reasoning eliminating... Oh, I think Ambrose saw it as Ambrose is asking the question. That is a 7, so it's orange. Now this cell, it knows it has an orange and a purple, so that's a blue, and now that's an orange, and that's a blue, and that's something else. That's an orange. So these are a 7-9 pair. Now that's the last orange for this column, interestingly. So neither of these are orange. This is definitely a 2 or a 3. This is a 1 or a 3. This digit... this digit is low, because if you look at what this digit can be, it can't be any of the high digits. It's C's 7, 8, 9. And it can't be any of the medium digits, so this digit has to be low, and it's not a 1, so this digit is a 2 or a 3. Let's see. I don't think I get any nice... I don't think I get any other nice things. I like arrow and sandwich, Logan. Arrow and sandwich is fun. Although I think I'm one of the few people who like sandwich puzzles, so maybe maybe it will not be as popular as some of the other choices that you could make. Let's see. So this column still needs some mediums. Let's see. Where is 5 in row 2? Asks someone, although then it got deleted. By the way, welcome, Andrew Clark. I'm not sure that I have seen you chatting here before, but welcome either way. This can no longer be a 5, because now this can't be a 4 or a 6 anymore. So 5s are not here, here, or here. This could maybe be a 5. That's definitely not a 5. So yeah, one of these 3 cells is a 5, I believe. It's not that one. One of these 2 cells is a 5. I have made it down to there. Let's see. Ambrose has a good point, I am told. Is it about arrows being good with sandwiches? Row 1, column 6. Sorry, I've now lost track. Sorry. Row 1, column 6 can only be 8. Row 1, column 6. Yes, it can only be 8 for literally exactly the same reason this one could only be 8. Great point. So that's an 8. That's a 2. Now, as soon as this is a 2, that's a 1, and that's a 3, and that's a 5, and that's a 2. So that gives us a whole bunch of stuff. Great spot, Ambrose. So those are my low digits for the box. That's a high. That's a middling digit, as Simon is fond of saying. This digit has to be high, and in fact actually has to be a 9. This digit now has to be low. Oh, that 3 actually gave me a 1 over here, just for bonus digits. This is a blue 2. It's a 1, that's a 2. Let's see. Okay, so now where does 2 go in this box? It can only go here. So that's cool. And so now I still look at the top of column 3. I'm not sure what for yet. I know that this is not a low digit because this sees 1, 2, 3. I'm not sure if this is what Barbie meant, but this cell sees 1, 2, 3, so it's not low. So it has to be high. And so therefore this cell has to be low. And now once I know that this cell has to be low, that's got to be a 1. This is an 8 or a 9. I'm not sure if that's exactly what Barbie was intending. If not, I am sure it will become clear in time. So these are a high digit and a 6. In fact, they're a, let's just fill them in. What are they exactly? They are a 6 and a 7. Except this digit can never be a 6, because 6 is not next to either of those things. So that's the 7, that's the 6, that's the 9, that's the 7, that's the 8. Not that. That's the 8. No problem, Barbie. We got there. I wasn't 100% certain if that was what you meant. If you had something else, I wanted to make sure we got it. That's a 4. I know it matters a lot whether you're typing on a keyboard or typing on your phone as you watch this. So people who are keyboard typers have an unfair advantage in terms of describing things more easily. These two digits are a 3 and a 6, and I know the order. That's the 6, that's the 6, that's the 3. So that's the 4 and that's the 6. The 6 is purple. The 3 is blue. So that's all the oranges for this column. Neither of these is orange. Neither of these is blue. Okay, I'm going to really quickly color this in my fake coloring, just so that I can hopefully disambiguate what the coloring is. So blue is immediately not green or gray. And so if blue is not green or gray, blue is yellow, which means yellow is blue, which means that that digit there is a 3, and this is a 1-2 pair. And it's not, and I never colored this 2, so it's as though it does not exist, but it actually does secretly exist. So I can put that 1 there because of that. That's a 9 and that's a 7. This is the 5 from the column. So I think I can't quite break up exactly what's... Oh, I can, because this sees every purple cell. This sees 4, 5, 6. And so this is not purple. So gray is not purple. It's high. The sentences we say. So that's a 7. It's the only high digit left. This is an 8 or a 9. So then by process of elimination, green is purple, meaning that that digit's a 4 and that digit's a 6. And then by further process of elimination, this digit's high and it's an 8 or a 9. Let's see. Adam Wyron says, by the way, welcome, Adam Wyron. Not sure I have seen you chatting either, but but great to have you here. 5s in boxes 1 and 7 via Sudoku. Beautiful. Okay, so that's not a 5 anymore. So that's the 5. And now that's the 5. So those we get to put in, and we get to purple them. Thank you for that. Okay. You might be able to tell this, but my favorite thing is when I know a cell is not a color because it sees every digit. And so this cell sees every blue digit. 1 and 3 in the column, 2 in the row. So that's got to be the blue, which means that's the orange. Now, this, if you look at it, the only way an orange could connect to something that's not orange is if it connected to a 6, but it's looking at a 6. So this is also orange. And so this is an 8, and that's a 9. And that's a 2, just by continuing around the room, so to speak. This 1 looks down, resolves that that's a 9, so that's orange. So we've got that. That 9 looks over. That's an 8. Oops. Or is yellow. Take your pick. That's an 8. That's a 9. This is probably a naked single, and it is. This sees every orange digit, every blue digit, and 2 of the purple digits. So oddly, this coloring makes it much easier to find naked singles. Let's see. So yeah, this is probably about to give up. So I need a 1 for this row. It has to go there. I need a 3 for the row. It definitely now has to go there. You're probably not very impressed by that deduction, but it's true. I know the 7 goes in one of these 2 cells, but I don't know which one yet. I think there's 2 kinds of people. There's people who coloring helps and people who coloring horribly hinders. I was about to place the 6 in this box, except spoiler, there's already a 6 in this box, so probably I should look at what's missing from this row instead, which is a 4. These 2 digits are a 3, which has to go there, a 3, which has to go there, and a 9, which has to go there. So that's an 8, that's a 9. The 3 is low, the 9 is high. So that's all done. These 2 digits are now a 6 and a 7. The 6 has to go there. The 7 has to go there. Purple and orange. These 2 digits are a 4, which I don't know where it goes yet, and an 8, which has to go here. 8 and 4. 4 is purple. Okay, so now we have to very carefully color because otherwise we'll accidentally finish the puzzle before we finish. This cell can't be blue, so that's the blue for the row. So that's a purple. No. So that's a purple. All the purples and all the blues are done in this column, so that's an orange. Now this box needs a blue. Okay. We are now in the clear to finish the puzzle because we have successfully colored. So that's a 7. That's a 4. That's a 3. And that's a 1. Very cool puzzle. If I'm completely honest, the riddle part is not for me, but I love seeing other people do the riddle puzzles, and I think the riddle puzzles are really cool, and you have really embraced the riddle puzzle genre, but I loved everything after that. Like I said, this is my first entropy line puzzle, but I really enjoyed it, and it lets you do tons more of the, this sees every one of 7, 8, 9, so it's not orange. You get to do a little bit more of that than in something like a whisper puzzle, because you only have to see 3 things instead of 4. and you get similar parity coloring because to a whisper line. So yeah, very, very, very cool. I like entropy lines a lot. I hope we get to see more of them. I was a little confused of there was a puzzle that Simon did on Patreon because it involved entropy lines because he felt it was too complicated, and I'm not really sure why it was deemed to be too complicated for the regular stream or the regular one. Hey, Kuraban. All right, so I'm going to take a real quick break. That was a blast. I'm going to pull up another puzzle, and then we're going to do another puzzle. Alrighty, I will be right back. But completely unexpectedly, we finished all the Fiveless puzzles. So we are now into Fiveless puzzles with fives. We'll be right back. Oh, okay. So from chat, I'm hearing it wasn't that entropy lines were too complicated for a Simon video. It was the other rules in the puzzle that were too complicated. Got it. Got it. Okay. So we've got here a puzzle I've been looking forward to doing for a long time now that we finally get along to. So this is a yeah, it's funny how far back in time some of these things end up being, because the bucket is a little weird in terms of the things don't necessarily come out of it in the order that they go into it. But this one I have been very much looking forward to because, well, it is a Renban puzzle, and I like cool Renban puzzles. So we're going to do it. And so Renban lines mean that the digits on them form a consecutive sequence. And I see we already have a digit immediately because the first thing you learn about Renban lines, and I think people sometimes overreact to this because they think it's huge and they immediately want me to pencil mark it in every Renban puzzle I do. And I don't think it's usually that useful, but here it's going to give us a digit right away. Every length 5 Renban has a 5 on it. And the reason for that is that if you tried to make a length 5 Renban without a 5, you'd have to make it out of the sequence of digits 1 through 9 without the 5. So you'd be making 1, 2, 3, 4, and then you'd run into problems, or 6, 7, 8, 9, and then you'd run into problems. And so as a result, I know there's a 5, and the given 5 is here why I was immediately willing to do this. It tells me that there's a 5 in one of these cells. And now this is also a length 5 Renban. It also needs a 5. Well, the 5 can't go here. And the key observation is if I put a 5 here, I actually rule 5 off of the entire Renban. But I need to put a 5 in this row. And I can't, in this puzzle, put it on top of the 7. So the 5 here actually is forced to go here. And by symmetrical logic, I have to put this 5 here. So this is a perfect example of using the Renbans of length 5 have to have a 5 trick to place some digits right away. So here are our digits. All right, let's make row 5, column 5 the bet cell. So you can choose based on this information whether you want the bet cell to be a 5 or you want the bet cell to not be a 5. It should be good times either way. Alrighty, so I know some of you are collecting Sudoku tricks. Here is one of Zeta's favorite tricks, which is, where does the 5 go in this box? Well, it doesn't go there, and it doesn't repeat on the Renban. And so this is always a good trick with Renban, which is to say, okay, the digits that are on the Renban can't repeat. And so what Sam has done for us here is to let us say there's definitely a 5 in this column. And likewise with this one, there's definitely a 5 in this row. And now we have 4 5s looking into box 7. And whenever you have 4 copies of the same digit looking into a box, you can place that digit so we get another 5. And so these digits we can fill in. They are from 3, 4, 6, 7. That one's not a 7. All right, so we're already off to a reasonably reasonable start, I feel like. Now, I want to know if I'm supposed to be asking about... okay. Yes, I am. Same trick. Where did these 2 digits go in box 1? They must go there. Sorry, they must go there. They were supposed to turn out the same color. It was supposed to be a like exciting moment, but it kind of didn't end up being one. Because neither of these digits is a 5, so they have to go there. So what that means is one of these digits is a 7, in fact. And the same thing happens, not there, sadly, but the same thing happens here. These 2 digits have to go there. And so one of these digits is a 2. Wait, wrong? Oh, no, don't listen to me. I'm crazy. Sorry. No, sad, no. Does it mean that I'm actually supposed to apply it over here? No, that doesn't work either. Sorry. What I was saying was complete nonsense, because I was saying they couldn't be here, so actually they have to be over here somewhere is what's actually true. I do that particular wrong deduction all the time. That is one of my favorite wrong deductions to make. So you'll probably see me do that again if you hang out here much. But yes, the point is these 2 digits, the correct statement is these 2 digits go here, and so then they go here, but that doesn't actually get me anything. So I don't think that's actually useful at this particular juncture. Let's see. So Sarvesh, I think, has the correct deduction, which is to note that I have a whole lot of length 4 Renbans without 5s on them. And so naively, what that tells you is that these Renbans have their digits chosen from 1, 2, 3, 4, 5, 6, 7, 8, 9, except not 5, and that doesn't seem at all useful. But actually, because of the fact that they can't use 5s, these digits are either all high or all low. So yellow is either 1, 2, 3, 4, 5. Sorry, it's either 1, 2, 3, 4, or yellow is 6, 7, 8, 9. Now, the question is, are these digits yellow, or are they not yellow? Which, seems like the kind of question that I would like to know. Oh, well, let's see. So these 2 digits in this box, so maybe I should say it this way. One of these 2 digits in this box has to show up down in this row. So one of the yellow digits actually ends up showing up on this bit. So there is a yellow in common between this length 5 Renban and this yellow Renban. So one of these 2 digits is yellow. And that's just by asking where these 2 digits go in box 2. Well, one of them could go here, but they can't both go here. So one of them goes down here, and so then the other one has to go up here. And so I can probably figure out... okay. I want to say that's going to tell me that these aren't yellow, because I'm going to be able to do the same trick that one of these digits is in common with one of these digits is in common with this Renban. So Nimazakli is asking, is it possible that both of these are yellow? Which is a good question. Is it possible that both of these are yellow? If both of these were yellow, then they would have to be 3, 4, because note, these 3 digits can't be yellow. These 3 are never yellow. So it's maybe worth coloring. These are a 5 and 2 greens. Green just being whatever yellow isn't. But is it possible that in fact these are 3, 4? So if this were 3, 4, then these two would be 3, 4. I don't immediately see why not. I mean, I'm assuming that it's correct, that this can't possibly be that these can't both be yellow, but I can't prove it yet. But I suspect Ni knows how to prove it. Yeah, so there's 2 not yellows on here, because nothing on here is yellow. I don't know. It's a question of mine, too. Well, it's a very good question. It's just a question I don't yet know how to answer. No, that's not useful. Yeah, 3, 4, or 6, 7 are the two. If both of these are yellow, then it could be 3, 4, or 6, 7, and that still seems plausible, although I suspect it's not what happens. Let's see. Jay says 7 can't go on the box 2, 3 Renban. Okay, so what happens if I try and put a 7 on here? Because that would be very helpful to know. If I try and put a 7 on here, let's say I put a 7 here. Well, if I try and put a 7 here, I can no longer place 7 anywhere in box 3. If I try and put a 7 here, I can no longer place 7 anywhere in box 2. So I agree. There's no 7 on this Renban. The 7, in fact, is over here. Okay. And so there's a 7 up here somewhere. And as Tallcat points out, immediately the same thing is true with 2s. Over here, if I try and put a 2 on these cells, I block 2 out of box 3. If I try and put a 2 on these cells, I block 2 out of box 6. So therefore, the 2 is in one of these cells. Josh says that implies the Renban is 2, 3, 4, 5, 6. Let's think about this. Okay, so no 7 on this Renban. So certainly, can this Renban have a 1 on it, I guess is the question. So could this be... No, it can't be 1, 2, 3, 4, 5, because this Renban has both yellow and green digits on it. But it can't have 7 or any number higher than 7. So that answers Nimuzak's question, which is that this has exactly 1 yellow. And so this is a yellow and a green up here, because this is, in fact, a 2, 3, 4, 5, 6 Renban, and these aren't the 5. Okay, and now The yellow is the one there's only one of, so the yellow up here is a 6, which means these aren't 6. So yellow now is 6, 7, 8, 9, but these aren't 6. Okay, these aren't 7, I should also note. So one of these is a 7. Okay, now, that definitely is sufficient to tell me that this Renban is green. In fact, there's a bunch of different ways you could now argue that this Renban is green. If we just apply the same argument, but replacing 7 with 2... Actually, wait, give me just a second. Maybe this is different. 7 and 2 are different numbers. But I think now... Yeah, so if this was 6, 7, 8, 9, I'm sure that breaks. Yeah, because I was, of course, half joking when I said 2 and 7 are different numbers, but actually 2 here is a lot weaker than 7 because 2 is closer to the extreme than 7 is. So yeah, I don't think we actually get completely for free that this is green. Now, what we do get completely for free is that these are all green, because these see the entirety of the yellow Renban, and by virtue of seeing the entirety of the yellow Renban, they can't be yellow. That cell is yellow because it is. Now, okay, so there's one more green cell and one more yellow cell to be had in this box, which is interesting. Yeah, we know that 2 is excluded from this Renban, but I don't think it gets us anything. Yes, so we started with not knowing which of green and yellow were high and low, and then it turned out that yellow was high. And I think the impression I get from chat is that people slightly prefer it if I don't change to blue and red when I discover what yellow and green are. Although you're welcome to voice in opposition to that if you prefer the other way. But this is one of those puzzles where it sort of started with us not knowing. Row 1, column 6. Must be an 8 or a 9. Yeah, okay, so yeah. Yeah, so basically, where are 7, 8, 9 in row 1? We have a 7, 8, 9 hidden triple in row 1. We know the 7 is here, so this is only 8 and 9, as those things go. So there's not a 1 or a 2. So I can say I know that there are a 6 and a 7 on this Renban. Because there's no 2 on this Renban, there has to be a 6 and a 7. And that gets me very little. But it does tell me that because there has to be a 7 on the Renban, this cell can't be 7. And because there has to be a 6 on this Renban, that cell can't be 6. Oh, that actually did get me something. That gets me that this digit is 6. Sorry, I was besmirching the good name of that cell unfairly. So I'll go over that again just in case you were confused. So we know there can't be a 2 on this Renban. That was one of the things we showed before. So once there can't be a 2, actually, the absolute minimum that this Renban could be is 3, 4, 5, 6, 7. So there's always a 6 and a 7 on it. And all of these 3 cells see the entire Renban. So we've actually ruled 6 and 7 out of all of these cells. And we knew one of these two was 6, so we got to place the 6, learn the location of that yellow cell, and then this could no longer be 7, so one of those two is a 7. I don't know which yet. I know now the 6 has to go in one of these cells. There we go. So the 6 goes in one of these, and this Renban doesn't have a 6 on it, so it's finally green. Okay, so we have now made our conclusion that we have wanted. I mean, it's all I've wanted. I don't know about you. Perhaps you're more indifferent. But all I've wanted this whole time is to color this the opposite color, and we can now do it. Because if this Renban were entirely yellow, it would need to have a 6, and it can't because we've placed 6s in such a way as to rule 6 off of it entirely. And so if it's not entirely yellow, it must be entirely green. So these are all from 1, 2, 3, 4. These aren't 2. One of these is 2. And now we can do a dance for the delightful 6, as well as for coloring the other Renban, which I am excited about. Yes, exactly. We should do a coloring dance for the Renban. I was already doing a coloring dance for the Renban before you even asked Tallcat. But yes, we're coloring the Renban. We are happy. This is what life is meant to be, is coloring Renbans. Okay. So good news all around. One of these is a 2. All right. So these 2 green digits. Oh no, never mind. I was about to make the same exact mistake that I made earlier, and that I think Tallcat just made. Row 2, column 9 is high. I don't see it yet. I do know that these are yellows and a 5, so there's 2 yellows and a 5 here now, because these see the entire green Renban. So these these cells aren't those yellows. Only 2 green in row 2, box 2. Yeah, there's 2 greens there. Agree. Oh, we probably need yellows here. Yep. Perfect. Okay. These cells are all yellow. Why are they all yellow? Well, they're all yellow because they're not 5 and they see the entirety of this. So for exactly the same reason that these were all green, these are all yellow. Thank you, Tallcat. The coloring is important. Row 2, column 9 can't be 1, and hence is high. Right, okay, right. This Renban we know the contents of. I didn't ever do this, but I should have. These 3 cells see 2, 3, 4, 5, 6. And so that means that these digits are from 1, 7, 8, 9. Now I know that one's not a 7. I also now know this one can't be a 1, because if this was a 1, this Renban would be 1, 2, 3, 4, 5, and that's not going to work. So this is a 1. So this is not 1. And as Sarvesh points out beautifully, that makes this yellow, which makes these 2 green. Because the column now is done. Okay, so this Renban has 1 green digit on it. And what is the 1 green digit it has on it? Well, it has a 4 on it. That's the only green digit it can possibly have on it. So These are not 4. And so, in fact, one of these digits is a 4. Let's see. This is a 1, 2, 3. Okay, and so let me write out what the contents are, because this can't be a 9 anymore either, because this has a 4 on it, and it can't have a 9. So the contents of this Renban are 4, which we already have placed, 5, 6, 7, 8. So these are from 5, 6, 7, 8. And so in particular, this cell is never an 8, because this Renban has an 8 on it, and this sees the entire Renban. Okay. So this is a 1 or a 9, which is a very interesting digit for it to be. Now, Barbie is pointing out, if I ask where this digit appears in column 8, well, I know in this box it has to appear over here, and so now it's forced to go here, so this cell is yellow. And I can probably do exactly the same thing here. This cell is in one of these cells in row 3, so it has to show up there. So I'll just flag that real quick. We are saying that's a pair of the same digit, so this is a 7 or an 8. This is a 2, 3, 4. So now that's yellow, because we need a yellow to finish off the box. That's green, because we need a green to finish off the box. So that's 1, 3, 4. Oh, and spoiler, it's not a 4, because we have a 4 in the box. So that's probably a good thing to notice about life. So there's definitely a 4 in one of these, for what it's worth. Let's see. I can officially gray the 5s, just so that we're keeping up with our coloring. Yeah, the Renban with 7, 8 needs a 6, which lets us do at least one elimination, and always good to do that when you can. In order to get from 5 to a 7 or an 8, I need a 6, so this cell's not a 6. Yeah, this Renban definitely can't have a 9 on it, is I think what Tallcat is saying. Oh, Tallcat's saying the opposite. This Renban... Okay, so what can this Renban be? It can't have a 9 on it, because if it was a 9, it would break this cell. This cell needs to have a value. In fact, this cell sees the entire Renban. So this cell is neither 6 nor 7, because the Renban definitely has a 6 and a 7 on it. So this cell's definitely an 8 or a 9. Unquestionably. But Tallcat's looking the other direction. And Tallcat's saying, how many green digits can I put on this Renban? And saying, I can't possibly put 3 green digits on it. Because if I try to put 3 green digits on it, although I could never have put 3 green digits on it to begin with, I can put at most 2 green digits on it. Yes, and 7643 won't work. Because if I put 7643 on it, I'm putting 2 green digits on it, which seems fine, except it's not, because I've used 4 134s. So there's no 9, but I can't use both 3 and 4, and so that means I know exactly what it is. So I need a 4, and then a 6, 7, 8. And that's exactly what this is. And since this is 4, 6, 7, 8, that is a 9. Excellent, excellent. So yeah, this is a green, a gray, and a yellow. If you want to get a little ridiculous with the coloring. And now, as Barbie points out, now these can't be 4 because these, again, see this line which has a 4 on it, so those can't be 4. So that is 4. Okay. And so now we get to do it all over again because we can come back down here and say, okay, I need to have a 4 in these cells. So the 4 is up here now in one of those. If I have a 4, it means I need to have a 3. So this cell is not a... no, if I have a 4, I need to have a 3. That's not how that works. That's not how any of this works. So this sees the whole Renban. Oh, sorry. I know I have a 3 and a 4. So this digit I know is a 1 or a 2. Okay. But how many yellow digits can I put on this? That's the question. And I think this is going to work out differently. I think this is where the asymmetry between the 7 and the 2, which hasn't really come up yet, I think this is probably where this is going to come up. Because I could put a 6 and a 7 on here, and that would be fine. Why is box 6's coloring off? I don't know what I did. When did I do that? Is that like forever ago? That was like forever ago. Okay, we're just going to just delete the color. This was probably an accident when I was coloring something else. Okay, so this is different. I could have 6 and 7 on this Renban and it would be okay, I believe. But I know at the very least these digits are not 3, 4, 5, 6. Actually, do I know there's... I know there has to be a yellow one here, right? Yes, there has to be a yellow one here. So that means that these are at least 3, 4, 5, 6, and then either a 7 or a 2. So these digits are not any of those things. So they are not... So they could be 1 or 2. They're not 3, 4, 5, 6. They could be 7, 8, 9. Okay. Yes, it definitely has a 6. Oh, good. Okay, yes, it definitely has a 6, because it can't, again... thank you, Andrew. Again, can't not have a 6, because then it would have to be 1, 2, 3, 4, 5, which would see this cell. So that's not going to work. So there is a 6 on here, which does place a 6. This is a gorgeous puzzle, by the way. This is really neat. So 6 over here. So now this digit's not a 6, and so we get a random stray color out of nowhere. There's a green digit down here, which means this can't be a 7 anymore. It also can't be a 4 anymore. So this digit can only be 3 or 6, which is very interesting. As far as things to know about digits go. Yeah, I know there's one yellow here. So I know one of these two is yellow, and one of these two is green. Do I know that? I don't think I know that yet. Do I actually know that exactly one of these is yellow? I have to know exactly one of these is yellow, right? Yeah, only one of these can be yellow. Don't I know exactly what's on this Renban? Why do I think I don't know what's on this Renban? Let's see. I could have both 6 and 7. Okay, yeah. I could still have 6 or 7. Okay. Oh, good point. Good point, Alima. Now that we've updated our pencil marks, this digit can never be a 3 this digit can never be a 3 anymore because of that. I was just sort of blindly following this, but yes, this 4, eliminating the possibility for this to be 4, also eliminated the possibility for this to be 3. So this digit is a 4, which actually places the 4 up here. Barbie says / everyone said that. Fine. I will contend, yes, everyone in chat except me saw that. So I know the 2 in this box is down here. So I know one of these 2 digits is a 2. Do I know which of those is a 2? Oh, and I think Medi is looking at this from the other direction. The 6 in box 2 has to go in one of these 2 places, I believe. Yeah, the 6 in box 2 has to go in one of these 2 places. So I think there's a very similar thing going on with the 2s and the 6s, but offset by a column. Ah, Tallcat has a beautiful, beautiful point. If this digit's a 2, then it places a 2 over here, which then removes 2 from being able to appear at all in row 8. So this digit is a 3, not a 2. Oh, I mean, I definitely can't put an 8 on this Renban, Nicholas. There's an 8-9 pair looking at it. That was really nice, Tallcat. So that means there's a 3 over here, of course. Which also means that this digit is a 6 while we're at it. So that is yellow. So that was a huge deduction. This is a 1 or a 2. Sorry, this is a 1 or a 2. I clicked the wrong cell. So that makes this a... oh, I guess I knew that this was a 3 already. So these aren't 3. Knowing that this is a 3 is actually the one that doesn't define this Renban, I think. Unfortunately. If this had worked out to be a 2, then I would know what was on this Renban. But there could still be a 2 on this Renban. I think. 2 in box 3. Ah, okay, yes. 2 in box 3 is now fixed. That's the 2 in box 3, thank you, because the 2's here looked over and the 2 there looked up. So that's the 2. And that resolves, Ken points out, that resolves the 1 and the 3 down here. Good. So that comes back and resolves the 9 there. So that's an 8, that's a 9. This is not an 8 or a 9. It's a 1 or a 7. But that being an 8 bounces back and says that that's a 7. So that's a 7. So that's a 1 and acquires grenadity. That's a yellow. I probably know what this digit is even. I think that's an 8, which coincidentally is the yellow with color. And so we get to actually do that and not have to immediately back up. So that's good. Oh, box 9 we can finish. Yes, box 9 we can finish in the same way. That's a 6. That's an 8. Okay, so... 8, I think, is placed in this box. I think 8 can now only go here in this box. Just by Sudoku. 8 sees across these places and down there. So this is an 8 and has been for quite some time, I believe, actually. So that is an 8. This cell sees every yellow digit. It sees 6, 7, 8, and 9. So this cell is green. So this is a 1, 2, or 3. It's not a 2, I know, because there's a 2 over here. So this is a 1 or a 3. Not sure which yet. So the question is ultimately if there's a 2 on this Renban or not. Like, that is our ultimate question. These are not 7. Good point. Okay, good point, Tallcat. So these are not 7. So that lets me say that these are, in fact, a 2 and a something else. A 2 and a 7. Which then, thanks to our glorious Given, Givens have done a lot of work in this puzzle, by the way. Tell me that's a 2. And that's a 7. So these aren't 7. And that answers the question. Now we know what this Renban is. Because now it can't have a 2 on it. And so now this Renban, because it can't have a 2, has to be 3, 4, 5, 6, 7. I'm done. Sorry, I was going to dramatically add an extra digit, but it turns out I cannot dramatically add an extra digit. That would be too many digits. So now, what are these digits? These digits are the other ones. 3, 4, 5, 6, 7, 8, 9. That's too many. Oh, so 8. No, 9. This can't be an 8, because if it were an 8, it would put a 7 or a 9 there, and that can be neither 7 nor 9. This can't be a 3 either, because if this were a 3, then this would have to be a 4 or a 2. It can be neither. So, in fact, this is a 5. What thing does 5 Renban? 5 Renban's a 4 and a 6, but it can't be a 4, so it's a 6. So, we've got that. And so now this is yellow. So now we've got all of our yellows and our gray for the rows. So these are green. These are a 1, 3 pair. I then write the wrong thing in. Those are a 1, 3 pair. These aren't 5. Now, this digit, Renban's this digit on a Renban of length 4. So this can't be an 8, because I can't get from 8 to 3. 8, 7, 6, 5 is the lowest I could get. So this now is fixed. This is a 3, which beautifully, this being a 3 actually fixes that that's a 1 and that's a 3. So we get to go through and fill in all of that jazz. This being a 2 made that a 1 and that a 2. Oops. That a 1, that a 2. How about that? Shinty 6. Shinty 6 is a good number. No one should be dissing Shinty 6 around here. Let's see. We got a yellow and a green. This is a 1 or a 3. Thank you. Thank you for pointing that out. I lost track of who pointed it out. Sorry. Okay, so probably we can do some damage over here in exactly the same way. So those aren't 7. So these digits are a 4, 5, 6, 7, 8, 9. Okay, if this were a 9, this would have to be an 8, and it can't be. If this were a 7, this would have to be a 6 or an 8, and it can't be. So this digit's a 4. I'm following up on the suggestion by someone in chat. Sorry, I've lost track again. To chase the same thing over here. So this is either a 3 or a 5. And disappointingly, I don't know if it's a 3 or if it's a 5. I probably should know, but I don't. I know these digits aren't 1, so I know this digit is 1. That's been available for a long time. This 1 looks over here and says that that's not a 1. Okay. So this 5, 7, 6... oh, no, sorry. Don't listen to me. I'm about to say something wrong. Okay, so if this is a 9, then these would have to all be yellow. Is it possible that all of these cells are yellow? Maybe. Unfortunately. If this is yellow, it's a 7 for what it's worth. But I don't quite see that it can't be. But I could ask myself if this were a 7, 6, 5, 4. 4 is the lowest this digit can possibly be. So this digit is a 5, 6, 7, 8, 9. But it's not a 6, 8, or a 9. So I actually know this digit's only a 5 or a 7. I don't know which one yet. But I do know there's a 5 and a 7 in here somewhere. This one, of course, is not a 7. I can fill in, actually. This is a 3 or a 5. It's probably a good idea to fill that in. 8 in box 2 via Tall Cat. Yes. Good point. I caught the 1 over here, eliminating the 1 from here, but I did not catch the 8 on here, eliminating 8 from those and placing an 8 there. Thank you, Tall Cat. I know one of these two digits is a 2, and one of them's a 4. So this is a 2-4 pair, for whatever that's worth. So, I mean, one thing it's worth is it lets me color. I now see what chat was talking about when they were saying you put a 1 on a Renban. I kept thinking when people were saying you put a 1 on a Renban, they were talking about this one, which I had just found. But they were talking about this one, which then let us fill those two in, which is great. Let's see. The bet cell is withstanding much better than in the previous puzzle. I can also note. This is not an 8 anymore. Yes, that's a good point, J40. This Renban now doesn't have a 4 on it. So these cells have to be from 5, 6, 7, 8, 9. That one's not an 8, for what it's worth. In fact, actually, neither of these can be a 9, because if either of these were a 9, it would make both ends 7, so that's not going to work. Let's see. See Sarvesh's point. Box 5 Renban cells are all even. Ooh, that's a really slick observation. I like that a lot. This is a length 4 Renban. This is a great spot, Sarvesh. These are all in a Renban, which means 2 of them are even and 2 of them are odd, just because when you alternate consecutive numbers, it has to work that way. And so these 2 are both odd. So that means neither of these is odd. They are not 5 or 7, which actually means they're 6 and 8. Gorgeous. This is a phenomenal puzzle, by the way. This is not an 8. Or sorry, this is an 8, so it's not a 5. This is not a 6, so it is a 5. So it loses its color, which gets this its full color that it has been denied for so long under suspicion of being a 5. So now this isn't a 6. Sorry. Now this isn't a 6. Yeah, now this 6-8 pair tell me that this is a 4. Why is there a gray on here? I don't even know why there's a gray on here. Don't ask. This is now a 4. So it gets granity. Now these are 6 and 8, so they don't get granity anymore. They get to be bold yellow. This 8 looks down there and says that's a 6, and that's an 8. Now, this 4 looks up and says that's not a 4 anymore. For whatever that is worth. Alrighty. 6 placed in column 2. Yes, 6 placed in column 2. Just didn't follow through. I eliminated that 6 candidate, but not that one. And then this 4 actually places the 7 in the 4. And that 4 places the 2 in the 4. So let's give these their color. like that. That was cool. I need a 2 in this row. It can only go here. I'm sure there's a better way to see that, but we're going to do it that way. The better way was to do it this way. That 2 sees over here and sees that that's a 3 and that's a 2. And then say, 2 by Sudoku goes over here. That was the smart way. But we didn't do it that way. We did it an alternative way. Let's see. This is not a 2. This is a 1-9 pair. This digit is a 1, 7, or a 9. Just by the row. These digits are a 7, a 9, and what? No, not a 4. A 3. I believe, if I read that row correctly. These digits are a 1 and a 9 and a 5. We still need a 5 in this row. The 5 is missing. Okay. There's not a negative constraint on Renbans in this puzzle. I have considered negative constraint Renbans before. That is that is something I have thought about but have not done. Okay. This digit is never a 7. Because if this digit's a 9, then this digit's a 7. So this digit's never a 7. Also, if this digit's a 7, this digit's not a 7. Let's see. Can I do anything similar to that? If this is a 7, this is a 9. No, that's not as helpful. Where is 7 in column 6? I am being asked to contemplate. 7 in column 6 is actually magically appeared here, which is going to be very helpful because what I should have said is this Renban definitely has a 7 on it. That would have been way less convoluted than the way that I actually argued it, but we'll make do with the argument that I made. And so that will do all of this damage. So we get to do some coloring. That was a great spot. Let's see. Not a 7. Okay. That 7 sees up that that's a 7. Sorry, that's a 9 and that's a 7. That 9 sees down that this isn't the 9. So 1 or a 5. This has way too many candidates marked in it. That's not a 2 anymore. That's not a 4 anymore. This has become a 2-5 pair, which means that that's a 4, and it can lose its shawl of grayness. Let's see. Leave it to directionary. Directionary will do the negative Renban puzzle. Okay. This can't be any yellow digit or 5, so this is green. And I know what green digit is. It's a 1. Which makes that a 5. Which makes that not a 5. Makes that not a 5. Makes that... which makes this a 5, because I do need a 5 in the row, as much as we might hope otherwise in this day and age. But sadly, we can't always have the things we want in life. So that 1 makes that a 9. The bet cell was a 1. So 9, that's a 1. 1, 1. Those are green. Those are yellow. Alrighty, and so now we should carefully color the rest of the grid before we accidentally finish the puzzle, because that is always a risk that we worry about. This is green, and this is yellow. Okay, the grid is colored. I'm going to de-black these cells, just because I think it'll make it look cleaner at the end. And now we can fill in the remaining digits. This is a 3. This is a 9. Uh-oh, I broke it. What did I do? How far back do I have to go? Is this far enough? I know that one of these two has to be a 2. So it's definitely broken here. Oh, why did I say this had to be a 5? I have no idea why I said this had to be a 5. No guesses whatsoever. Who knows? Okay. This digit sees every yellow digit. So it's not yellow. This digit's not yellow. So one of these two is yellow, but unfortunately I don't know which of them it is. I should clean up this, as is being pointed out. The 1 looks over there. This makes that a 3, makes that a 1. These are a 2 and a 9. These two are a 3 and a 5. Yes, I was doing a complicated proof that cell could not be a 5. This 3 looks down and says that is the 5. Okay. Coloring time. So this is going to be green. This is going to be green, so that's going to be gray. That being green is going to make that yellow, which is going to make that green, which is going to make that yellow, which is going to make that green. Okay. Sometimes as part of these puzzles, the trick is you have to do the last bit in your head so that you finish the coloring before you finish the puzzle. Okay. So there we go. So that 1 sees that that's a 9. Alternatively, the coloring I could just use. That's a 9. That's a 2. That's a 3, which is good because it's different than it was before. The bet cell was a 1. Apologies if you had 9. It's a 2. That's a 5. Uh-oh, the column 1 colors are wrong. Oh, no. Oh, no. Oh, no. We broke the puzzle. We've got to go back. We have to go back, Kate. Okay. Okay, so that's going to be yellow. That's going to be green. No! Okay, let's try again. 9 and 1. Is it right that time? Hopefully that is righter. Yes. That is my old show of choice, to pretend is a current and hip reference to make Tall Cat. I'm missing a number in box 2. Oh, people like all the numbers filled in. So we got rewarded for filling in all the grid twice, and we're still going to de-blacken these cells just to make it look a little nicer to finish it up. There we go. That did not de-blacken the cells. That only made the blackening of the cells worse. There we go. Nice puzzle. Yeah, this was a great puzzle. I love Renban. This is a really, really nice Renban, too. So many cool little steps. There's a lot of neat stuff sort of packed in here. Alrighty. I kind of don't even know what to say about I mean, I hope you love it. You set the puzzle. Hopefully you love all your puzzles, right? Is it knowable in advance that these two Renbans are going to not have 5s on them? Should I have seen that somehow? Like, it's interesting that neither of these ends up having a 5 on it. I certainly did not see it as I was doing the puzzle. You have a killer puzzle, Tall Cat? Man, I have not looked at people's puzzles in so long because I've been doing Caterpillar and Fiveless puzzles and all these sorts of things. All right, I'm going to take a quick break. Enjoy the music. Enjoy looking at the names of our patrons, who we greatly appreciate. And I'll be back with some other puzzle in some amount of time. Welcome back, everyone. Yeah, I think perhaps my best Renban puzzle that I've made is somewhat unfortunately called 159 because it was made before 159 was a thing and has nothing to do with the 159 constraint. And then, somewhat amusingly, I made a 159 puzzle that uses Renban, but that's not called 159. But anyway, if you want to see a weird Renban puzzle, you can go back to like before Renbans were purple. And then I had one there. All right. Good night, Nicholas. All right. So we have a puzzle by Chat Regular Kuraban. That is some sort of puzzle. I do not know. I pulled it out of the document because I honestly was not expecting I would get to any, much less two puzzles with fives in them today. So let's read the rules carefully. So normal Sudoku rules apply. The first two digits in each cage, read from left to right, give the total for the cage. All digits in that cage, including those two, must sum to this total. Digits in cages must not repeat. Every cage total is unique. Anti-knight rules are in effect. So that is two cells that are in knights move away can't be the same. So these two are definitely not the same digit. And that's it. And by the way, if you have another Renban puzzle, the Kagito, you can be almost certain that in my prowling, I am going to find the other the other one and do it eventually on stream. It is only a matter of time. Okay, So first thing I see is that this digit has to be a 3 or a 4 because it is summing 8 different digits. And so you're asking about consecutives that are diagonal. I think Ranks has some puzzles that involve like a dot where you're supposed to read it as the diagonal digits are consecutive. I believe. So this has to be 3 or 4, and now this one is also of size. This one's also of size 8, so that's a 3 or a 4. This one is also of size 8, so that's a 3 or a 4. Now this one is a little bit worse. This is of size 7, and so by being of size 7, it actually could squeak in to having a starting digit of 2. So this is only from 2, 3, 4. This one is from 3 or 4 because this is of size 8. This one's only of size 6, so this is also 2, 3, 4. And I know which one it is before you point it out. Go ahead. You could be the first one to point it out. I will let you. But there we go. Okay, so there's all of our sort of given information. And the first thing I see right away is that we get this digit has to be a 2. And that's because, again, with 6 digits, I'm getting to a minimum of... with 6 digits, I'm getting to a minimum of 21. Yeah, so people are pointing out in chat that actually, if you actually think about it, you can eliminate 2 from this option. So I think the way people are thinking about it is dump the units digit and sum these digits. Can those digits sum to 20 is really the question. And so you could get sorry, I think I'm saying this backwards. These digits would sum to a minimum of 21. Yeah, these digits sum to a minimum of 21. This is the way to say it. These 6 digits sum to a minimum of 21, which means that when I throw in this digit, I'm going to have a cage that is too many. So actually, this can't be 2. I'm going to color the 3 4s real quick because it seems like that is going to be a helpful thing to do. Let's see. That one's definitely orange. I don't know what this one is yet. Okay. So, let's try and do some Sudoku, shall we? Can I place orange in this box? I can place orange in this box. Orange in this box has to go here because it can't repeat in the cage. Oh, is orange in row 4? Did I just randomly color something for no reason? I totally just randomly colored something for no reason, didn't I? How did I do that? I don't know. Don't even have the slightest clue. Which is unfortunate because this is the one I can actually place. So I think that's the one I actually should color. So we're going to color this one and then go backwards. So this one is definitely here in this box because it can't repeat in the cage. Oh, wait, no, it could be here. Darn it. No, never mind. I don't know. I don't know anything. We're going to think about other things. Let's see. These 4 digits need to sum to 18 exactly for whatever that is worth. Okay. Yeah, the 40 plus is quite restricted. It can't be 45. It can't be 44, obviously. Could be 43. So for this one, it could be, if this is a 40-something number, it could be 43 if this is a 2. It could be 42 if this is a 3. And but this one in particular can't be 41 because that would have to be a 4. But I presume this one could be 41, for example. Oh, and this one can't be 43. That's a good point. Because of the row, yes. Okay, so this one actually, if this is 40-something, it has to be 42 exactly. So what you could say here is between these, I kind of have 3/4 of a 1, 2, 3, 4 quadruple. Yeah, one of these is a 41 or a 42. All cage totals are different. I had already completely forgotten that all cage totals are different. Okay, row 4, column 7. Yes, Ambrose, but the other one I think is a lot less restricted. I think this one could be, I mean, it can't be 44 or 45, but I think this one could be 41, 42, or 43 without being an issue. 3 in row 2 is in box 3. That's a good point. One of these is definitely a 3. Aren't there 3 possibilities for 40-something? Can't it be 41, 42, 43? Row 7, column 4. I don't understand this argument because you can't have a 41 sum. Oh, right. Sorry, I was thinking about this being in terms of the box, but you're completely right. I can't have 41 because then how am I making 41? Right. Sorry, Russ is completely right. It can't be 41 because it has nothing to do with the box or anything like that. It's just the cage itself. How am I making a sum of 41? Well, I'm either omitting a 4 or I'm omitting a 1 and a 3, neither of which work. So right. So I have to have a 42 and a 43. That is the point. And so once I have a 42 and a 43, which I have, that tells me these other two are 3. Because 42 and 43 are the only totals that I could make. And therefore, these have to start with 3. So that's not a 3. Because I will remember that this is an anti-knight. Oh, if I had remembered this was an anti-knight, I would have already known this wasn't a 3 because I would have paid attention to that, but whatever. Okay, so 42 and 43 are the only totals that are valid. 41 is not possible because a cage that summed to 41 would be missing a 4, which is not possible, or missing a 1 and a 3, which is not possible. Okay. Right. I can't have neither of these as the 43 because there's already a 3 gone in the row. Excellent point, chat. So, and this isn't a 43 for myriad reasons. So the only place I can actually put a 43 is here. Gorgeous. So now one of these is a 42. Is the... Oh, sorry. One of these is a 42. Actually, I know which one, because Sudoku. That's the 42. Okay. Oh, wow. Russ with the sweet, sweet spot. 4 is now a hidden single in column 2. Because it can't repeat in this cage or in that box. And Anti-Knight says it's not there. And then that says it's not there. So that's a 4. Jaw-dropping. Good night, Chip. Glad you enjoyed it. It's been a lot of fun today. Okay, now... Okay, now 3 is placed here in this box. For real this time, because that 3 looks over and sees that the 3 can't go there. It can't repeat in the cage, so that's all good. I need to put a 4 and a 3 in this box. I can put neither of them here. I can't put any of them in this cage, so 3 and 4 are in this column here. That one's not 3 for multiple reasons. The 43 cage is missing a 2, so I know the 2 in this box is actually in one of 3 places. It's in one of those places. Ah, but it's not in either of those places because of Anti-Knight. The 2 is actually placed there because of things. Oh, and the Anti-Knight at 3 actually sees that that's not the 3. So that's the 3. Okay, so we've got lots of Anti-Knight shenaniganery going on. The 3 down here needs to go in one of these cells. Needs to go in one of those 2 cells, actually. Okay, so this 20-something cage has a 3 in it. And that tells us where the 3 in box 3 is. So that's the 3, and now our 3 is done. Not quite, but that's the 3, and now 3s are done. Okay. I fear we're about to run out of gimmies, though. Okay, so let's fill in what this digit can be. Okay, so I need to get a 30-something number. So if this were a 6, this would be 39. If this were a 7, this would be 38. If this were an 8, this would be 37. And if this were a 9, this would be 36. And so these are also from 6, 7, 8. Oops. This is also from 6, 7, 8, 9. Let's go ahead and fill in. The 2 in this column actually can only go in one of these 2 places. Okay. I need to get these digits to sum to 20, which means I need to get these 3 digits to sum to 15, which unfortunately is not actually all that difficult, I suppose. Let's see. Do I know that 4 has to show up in here? Yes, because this is an 8 size cage. Okay, I'd not appreciated that. SBQ has a pretty neat observation. This is a size 8 cage, so it can't be missing a 4. And there's only one place a 4 in it can go, just by Sudoku, so that's a 4. Very nice. Yeah, the digit that this is missing has to be at least a 6. And so in particular, I should go ahead and fill in that this is 6, 7, 8, or 9 while I'm doing that. This is also a size 8 cage, so this is also 6, 7, 8, or 9 in order to make that work. See, I know one of these is a 4, which I'm going to mark only because this is anti-knight. Actually, that's not the 4. One of these two is a 4. Yeah, maybe that's not super. Okay, so one of these is a 4, but that's not great as these things go. Yeah, this is a cool rule set. I like puzzles with this sort of thing. I've done a bunch that I've enjoyed, and I've set a few that I've enjoyed. Okay, this cage definitely needs to have a 2 in it. That 2 needs to go in one of these 2 cells. Oh, let's see. Someone is pointing out that 2 has to go in one of these 2 cells. But if 2 went here, it would break column 2. So 2 can't go here. So that is a 2. Gorgeous spot, by the way, Genevieve. That is a really subtle but really great spot. Okay, so the 2 now over here has to go here because it can't repeat within the cage. So that places the 2 here. Now I need a 2 in this box, and it can only go there. Okay, the 2... Now the 2's here. Do I have all the 2's now? Almost. The last 2 goes there. Okay, so now we've got all the 2's. We've got all the 2's. We've got all the 3's. And I was instructed to look at 4's in box 8 and see if I could find one. Let's see. That's not a 4. So one of these 2 is a 4. Is there a reason that this cage can't... that this can't be a 4, or that this can't be a 4? Let's see. I've got to look for 4 pencil marks. It's probably an anti-knight thing that I'm missing. Why was 2 in box 6 placed? When did we place the 2 in box 6? Let's see. How far back do I have to go? Okay, so here we go. Okay, so we're there. Now 2 is already in this column. It's already in this column. And by anti-knight, it can't go here, so it can only go there, SBQ. Very daring to combine this rule set with anti-knight, by the way. That is quite ambitious. But seems to be going very well. Oh, could go here. Sorry, it could be here. You're right. Okay, so 2 I know is in one of those 2 places, but I don't know which one. Okay. We have unfinished the 2s. I do still get to place this 2 there. I still get to place this 2 here. That's still good. And then it's just, I don't know which of these 2 is 2. Okay, so we got a little X-Wing on 2s because we got a little excited. But yeah, 32 is definitely possible for a 7 cage. At least as far as I can tell for the moment. Okay. What are digits that I know where they have to go because of anti-knight plus cage logic? That is what I would really like. Like this digit. Where does this digit go in box 5? And I think if I've done my anti-knight correctly, it's not in any of those places. It's not there and it's not there. So I think it goes there. And now, this digit is a 6, 7, 8, or 9, so it's not a 3, so it goes there. Let's see. It's not there. It's not there. Okay. This digit has to appear... that's not quite right. Okay, that was not... it's not immediately helpful. Where else can I do the same game? Anywhere else where I know where a digit goes somewhere else. Like this digit, whatever it is, goes in one of those 2 cells in the 42 cage. Is that worth tracking? That does not seem useful. Yeah, this cage has the weirdest geometry, so it does seem like a good place to look. Row 5, column 7. Unfortunately, I think row 5, column 7 could go either of these 2 cells in box 5. Purple is in row 4 in box 4. Good point. Purple is up here somewhere. Okay, we will market that. So now purple is in one of these 2 cells. Because it can't, again, repeat in the cage, because that's how we started with the whole thing. Good point. Box 9 in 2 spots. Not in any of those. Not in those. Not there because of anti-knight from that. I'm getting 3 spots. Alima sees something I don't. I mean, it is worth pointing out, I suppose. One of these is purple, which is going to let us say that purple is placed up in one of these cells. And since purple has to appear in the 43 cage, purple is actually in one of these 2 cells. So that lets us place that one of those is purple. Yeah, but the 3 cells don't line up nicely, Riff Clown. Coloring it like that just seems dangerous to me. Yeah, these 2 are both none purple, so we can start chasing those around too. Yeah, these are both not purple. Actually, do I know this one's not purple? That one could... No, that... Wait, this one could be purple, right? No, it can't... Wait, no, this could be purple. Let's see. Sam says... But it... Oh, sorry, this is a 30 number. Somehow I thought this... Yeah, this is not purple by the rules. Good point. Okay, so these are both not purple. So yeah, so the purple in here is in one of those 3 cells. And it can't be... No, it could be in this one. Never mind. Could be that one because there. Okay. Sorry. I thought one of these started with 3 and one of them started with 4, so I thought the totals were different. But obviously that is not the case. So yes, that can't be purple. Yeah, we can go ahead and just give these colors just so that we can talk about them with colors because people like names for things. It is, I suppose, worth noting one of these 2 cells has to be blue right away. Whatever color you want for blue. Row 2, column 5 is placed in row 1. Sorry, row 2, column 5 is placed in row 1. Ah, right. Good catch, Barbie. This cell is blue because I need to put it in row 1 somewhere. It's not 3. It can't repeat anywhere in this cage. It can't repeat within the box. It can't repeat there because of Knight's move. So that's blue. Beautiful. So now one of these 2 is blue. So this is a 4 blue pair. So blue in column 4 now is only in a couple places, although they're not easy to mark. Can I explain the column 1 blue coloring? Yes. The 43 cage needs a blue, and the blue sees all of those cells, and blue isn't 4. So blue has to be in one of these 2 in the 43 cage. That was my reasoning. Oh! Knight, I missed that. Right, sorry, I highlighted 2 points, but one of them doesn't actually work. Yes, excellent. Blue in column 4 only now goes here, because this is ruled out by the Knight's move. So that's blue, which is great, because it means this isn't blue, or gray. So this is blue, which is even greater, because then it means that this is now purple. because now it's the only place for purple, which now means this isn't purple. Blue is now in one of these two cells. Row 4, column 4. So do we know anything about row 4, column 4 in terms of anything that makes us want to color it? What color is it? Do we know what color it is? Like, do I know it's not... Okay, I know it's not blue. I know it's not purple. I guess I can just decolor orange and just color this orange and then not think about it. Because this is not blue or purple. I'm trying to figure out where I get any progress with this. Yeah, it's not 2, 3, 4. I agree that it's not 2, 3, 4. Box 2. It's not those. It's not that. Ah, okay. Yeah, I agree. That goes there. So now orange down here. Well, it's not 2, so orange is in one of these two cells down here. Blue is in one of these two cells. Row 7, column 5 is orange. Because otherwise orange is missing from this cage. Why does this cage need to have an orange? Yeah, I don't know that orange is 6, 7, 8, 9. It's possible that people in chat know that orange is 6, 7, 8, 9, but I do not know it. But there are cages that need to have every 6, 7, 8, 9. And so, for example, like this cage, no, this cage does not need to have every 6, 7. No, this cage needs to have... No, this cage needs to not have every 6, 7, 8, 9, actually. So blue could very well miss this cage. We know the box 8 cage sums to 45 minus blue. Do I know there's not a blue in this cage? Like, couldn't there be a blue here? Oh, no, because there's a blue in the row. Got it. Okay, yes. This cage does not have a blue in it. Okay, fun fact, those two blues there rule blue out of this entire thing. Okay, so blue is the one color that is missing from this cage. Nothing else could be missing. So orange has to appear in here somewhere. Yeah, and so this cage sums to 45 minus blue. Agree. So now blue in box 9, yeah, blue in box 9 is in one of these two cells. Oh, that's interesting. Okay, blue in box 9 is in one of these two cells, and blue in box 9 being in one of these two cells, which has nothing to do with anything we were just talking about, just gives us an X-wing on blues, which tells us that blue in this box is in one of these 3 cells, and Well, we're just going to do that. So row 3, column 3 equals row 7, column 5. Right. So I agree with that. Those two are the same color. But that color, unfortunately, might or might not be orange. Like, I still feel thrown by this coloring the orange cell. I think people saw something with the orange cell that I have not yet put together. But it's true to say that if 45 minus this color is 30 blue, then 45 minus blue is 30 this color. We know where blue is in box 4. Blue is not in row 4, column 7. Oh, unique totals. Good point. Okay, yes. I can't repeat the total. If I put a blue there, I'm not, which then gives us this X-wing, which removes blue from here, which places blue here, which places purple here. Gorgeous. Great spot, Ken. So now this... Oh, I guess that cell already wasn't purple. Never mind. One of these two cells is purple. Right. And so now we've resolved our mess with the 2s. Good point, Sam. Because now that this is 2, it's now that this is blue, it's 6, 7, 8, or 9. So that's a 2, and that's a 2. That's not a 2. All good points. So I kind of want to get rid of my orange coloring and color this cell, because I think that might be more helpful. We can always bring back the orange coloring later if we need it, but I want to color this cell. I'll make it green, because as pointed out, this I know is green, and this strikes me as the key identity, that blue and green are related in this way, so this cage not having blue means it sums to 30 green, to balance this out. So now where does green go? Down here. Well, green definitely goes in this cage at least. Let's see. Where is green in box 9? Green in box 9 is with blue. Because green can't repeat anywhere in here, can't repeat there by Knight's move, so green and blue form a pair here. This is a green-blue pair. So then green over here is in one of these two cells. Green does have to appear in 30 purple. Green has to appear in 30 purple, and green appearing in 30 purple, as J40 points out, can only happen here. So this cell is green, which has manifold consequences, because it means this cell's blue, this cell's not blue, this cell is blue. Very nice. So now if I look at this box, green is placed here in box 4. the one piece there that was not just Sudoku is that these two cells being the only two places green can go means green can never go in these two places, because no matter which of these is green, it will rule it out of both of those. Which now means that this cell's not green, which means that this cell is green. Let's see. Green does need to make an appearance in this cage. Green has to show up in 42 cage. So green's up in one of those two cells. Now, green has to be in one of these two cells. That doesn't feel useful. Oh, green has to go here, because green has to show up in box 5, and it's only got one place. That was much easier than any of the other available options. Okay, so now green in this box now is placed here. So we've got green. Okay, so how are we doing on greens? We've got a little X-wing on greens, but all of our greens are otherwise placed. So green was the original orange. Before we had the rogue orange. Okay, so now this orange, maybe this orange has come into its own now. So this orange was originally there because it could be placed in box 2. This orange went there in box 2. So can we now do anything? Has orange become more potent now? Yes. Now orange gets placed here in box 8. So now orange is doing work. Orange has a couple places over there. Orange can't be excluded from this cage. So orange is in one of these cells. I don't know which one yet. Orange has to show up in the 42 cage. So one of these two cells is orange. Those are the... No, sorry. Orange could also show up over there. Yeah, orange is purple's partner. Because, wait, does it have to be purple's partner? Why does orange have to be purple's partner? Where is that? So have we excluded orange completely from... Yes, we have excluded orange completely from this cage. So we have now proven that because orange is excluded completely from this cage, and the digit excluded from this cage is 6, 7, 8, 9, that tells us that this is 6, 7, 8, 9, which, as stated, means that orange and purple go together. So that means the purple cage... Do I have a 30 purple cage? No, sorry. Do I have a 30 orange cage? I don't think I have a 30 orange cage, unfortunately. So the fact that we don't have a 30 orange cage does mean, I believe, that orange has to show up in every 8-cell cage. Purple has to show up in every 8-cell cage other than that one. So row 8, column 7 is not purple, or else the sum gets too large. Let me look at that closely. Row 8, column 7. I see, sorry. Okay, so, right. So these two digits are definitely 6, 7, 8, 9. And so the question is, could I have 3 6, 7, 8, 9s in this cage? And the answer is no. In fact, I probably know what this digit is, actually, because this is a sum of 2, 6, 7, 8, 9s, and I know these 4 cells sum to 20. No, sorry, these 5 cells sum to 20. So let's figure that out. I agree that this cell can't possibly be 6, 7, 8, 9, but what could it be? 6 and 7 is 13, plus 5 is 18. Wait, I must be doing math wrong. What could... Oh, sorry. 1 is a number. Right. I remember someone saying 1 is a number. Okay. So what is the absolute minimum that these digits could sum to? And the answer is 18, which means this digit must be 2 or smaller. Well, it has to be 1. And now once this is 1, I need these two digits to sum to 14. Well, then they have to be 6 and 8. Okay. So these are 6 and 8. Now, that means, of course, this is not 6 or 8. Orange is 6 or 8. Orange is 6 or 8. Now, orange is purple's partner, so that means orange is not 6 or 8. Orange is 7 or 9. Sorry, purple is not 6 or 8. Purple is 7 or 9. I should say that correctly. So this is 7 or 9. And now we have a purple X-Wing. Gorgeous. Thank you, Russ. And now our purple X-Wing is going to tell us that purple goes here. And so now that's purple. I love puzzles like this, by the way. This is like the zetamath guilty pleasure kind of puzzle. So we've got that all going for us. So we've got lots of stuff placed. Okay, so orange... now where does orange go in this 30-something cage? Orange now has to go here, just in box 1. So this is our 6 or 8. In particular, we now have a quad, so this is a 1-5 pair. Okay. This 30 cage needs a 1. It's not missing a 1. The only place the 1 can go is here. So that's a 1. Now, the 43 cage also needs a 1. Oh, but sorry, it could go there. Never mind. I, again, was getting excited. Oh, but this 42 cage needs a 1. And the 42 cage can only get a 1 now here. So this is a 1 green pair. Directionary is making a much simpler point, which is that 1 is just placed in box 5, which, thank you, very much appreciated. 1 in box 2 is placed by this argument about the 1 being there. 1 is in one of these two places in this box. So 1 is in one of these two places over here. So this is a 1 purple pair. All right. Oh, yes. And as Riff Clown points out, we now have every digit put in box 5. So good job. Riff Clown is correct. This is now a 5. Gorgeous. Okay, what's missing from this row now? We've got 1 purple. Okay, orange is the only thing now missing from row 5, right? Orange has to go there. We have every other digit placed. So that's orange. And so now orange in this box has to go here. So now orange in this box has to go here, because remember, this is a 1 green pair, so it's not orange. So now orange, the last orange, I believe, is placed there. Oh, it's not the last orange. There's 1 more orange, which goes here. Okay. And so the Cogito's orange has now done its wonderful work here. So we've got all those oranges. We've got all the purples. Okay. 5 in row 2. Oh, wait, row 2 is, well, it could be in either of these, can't it? What am I missing? Something, clearly. I know 5 is in one of these two, for whatever that's worth. In fact, this is a pair of a 5 and what? Oh, this is a 4-5 pair, right? This is a 4-5 pair. Those are the things that are missing from this row. I haven't done 4s in a while. Do I know anything else about 4s? Well, yes, I do, because now I have an X-Wing on 4s. between that box and this box, which places a 4 here. And so that 4 now sees that cell, which places a 4 here, if we believe our pencil marks. Now this row is now only missing a 5. So that's a 5. Now this box is only missing a 1, so that's a 1. That 5 fixes up here that that's a 1 and that's a 5. Okay, so we're doing good. Okay, this is now a 5 because it's the only place for a 5 in the box. Or sorry, it's the only digit we're missing in the box. Put a different way. Let's see, we've got 1 green, 4 blue. What's missing in this box? We've got all the colors. We've got 1, we've got 4. Oh, this is the 5. We're missing a 5. That's what we're missing. That's a 5, which resolves that that's a 5 and that's a 4. So more digits go in. So that's a 4 and that's a blue. So this is not blue. This is blue. We can get rid of our corner mark. That fixes that this cell is green and this cell is blue. That fixes that this cell is a 1 and this cell is green. So you lose all your color. You become... No, I did that backwards. You lose all your color. You become full green. So this is a 7 or a 9. Okay, all the greens are 7, 9. I'm going to go ahead and fill that in. Not the 2. The 2 is not 7, 9, spoiler. This is not 6 or 8. Not 6 or 8. Okay. Now... yes, and now we have 5 in box 9. Thank you, Riff Clown. So 5 in box 9 goes here. So this is not purple. This is purple, which means this is not purple and is 1. And this is purple and is not 1. It is not 1. Thank you. So now this box needs a 5, which goes here. This box needs a 1, which goes there. And this box needs a 5, which goes there. And I think now... Oh, this cell. What is this cell? This cell's a 4. Okay, and so now I think everything is... now I think everything is done. So these are 6, 8. This is not 7 or 9 because it's 6 or 8. Okay, and so now we want to look at this box because this box sums to 32, but I can also just do the math. That's 10, that's 11, that is 25, and so this cell needs to be a 7. So purple is 7. And now everything falls apart because now green is 9. And now my 39 cage needs to be missing a 6, so orange is 8. And now blue is 6, and then we're done. Wonderful puzzle. What a great way to, what a great one to go out on. Excellent job, Kuraban. I can only imagine how long this took to set. But this is so many things I love packed into one puzzle. Yeah, this is just gorgeous. Let's see. I think there's an LMD link up there, right? You should go rate this on LMD if you enjoyed it. That is my advice. Great puzzle. Look forward to doing more puzzles by you. Yeah, that was a lot of fun. Alrighty, well, it's probably about time to wrap up stream for tonight. Don't worry, there will be more Zeta on Wednesday, so you don't have to wait that long to get more Zeta in your life. So we're going to be back to trying to clear out some puzzles from the bucket, and I'm going to probably go scrape all of Logic Masters Germany and the Discord Puzzle Archive and all of those sorts of things. Because I haven't looked at those in a while because I've been doing Caterpillar and Fiveless puzzles and all of those sorts of things. So then there's going to be even more puzzles to do that I'm never going to actually get to because there's too many great puzzles. But a great problem to have is that there are too many great puzzles in the world. So I am not displeased with this. Unfortunately, there are many of us who make content related to doing puzzles. So if I don't do a puzzle, likely Ranks will do it, or Scott will do it, or whatever. So all of that and more is coming to you soon. Have a wonderful, wonderful day. Don't forget to like the stream. If you have not yet subscribed to the channel, I would really ask you please to subscribe. We're not that far away from 1,000 subscribers. When we get to 1,000 subscribers, it makes a huge difference in how YouTube treats the stream and how YouTube treats me as an individual. My math channel made it to 1,000 subscribers, and then that really made things a lot easier. So would greatly appreciate if you're not subscribed, if you could subscribe. Love seeing all of you a couple times a week. Please come by next time. I'll see you then. Have a great evening.